Check, 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 check. 1 2 1 2 1 2. 1 2 1 2 1 2. One two one two 1 2. Kelsey, this is Jim. I'm going to turn on my microphone. Now you can check the feed from my room. I forgot what's my topic. I'm research. All right. Mic check 1 2 3 1 2 3 4. This is Jim from the research room. 1 2 3. Jim from the research room. Doing a mic check for the stream. Mic check for the stream. Mic check for the stream. 1 2 3. Are you picking me up, Kelsey? 1 2 3. I'm going to turn my microphone off. If someone has their headset on, you could flip the microphone up and it goes silent. time. Get yourself organized.
I'm gonna run to the restroom and then I'll.
Yes. You know what? I'm going to do that too. Hey, Tim. Hey, Tim, by chance, do you wear the master? Okay. It's breaking up a little bit. You want me to wear the master? Just give me one word. Who wears the master? check, check. Check, check, check.
Okay, hello, Jim. Check, check.
Is that your speaking voice?
This is probably my speaking voice. Does that sound good?
Yeah, now I'm in this tunnel. Let me just say, this is my speaking voice up the top.
All right, this is my speaking voice. Hello, everyone. Test, test.
Ron more to sleep.
No falling asleep. Hello, everyone. I think we'll give everyone a couple more minutes to make sure they're finding the rooms. session? Okay. That will be me, yes. Ah, okay. That's what I'm hearing. It's, yeah, people are having difficulty finding. Hopefully they'll redirect. We got a couple more coming in.
Nobody knows where to go. They're all kind of wondering.
All right. Sounds like people are trickling in, so. All right, folks online, we are getting ready to start up here in the research room. We have a good crowd in person as well, so if you'll give us just about another minute, we will go ahead and get started. All right. Well, I think we will just go ahead and get started. So we're good, Jim? All right. Good afternoon, everyone. Hello and welcome to the first session in the Research Breakout Room at Soybean Summit. My name is Jennifer Jones. I am a certified crop advisor and a research agronomist here at the Illinois Soybean Association. Helping provide answers to farmers' soybean production challenges and questions is a priority for the Illinois Soybean Association. From conservation practices to in-season agronomy to pest management, we work with researchers to curate research studies for which farmers are asking. So in this session, I'm going to be presenting some summaries of recent findings from Chekhov-funded research conducted by experts around the state to learn about how you can steer the direction of future research studies as well as farmers. So before I get started, as a reminder, if you have any questions, feel free at the end. We'll have a Q&A period, and we will have a microphone that we can pass around so that the folks online can hear us as well. And then folks online, if you have questions, please put them into the chat on YouTube. So, all right. And I am moderating this whole research breakout session today, but I am also your first speaker, so I will go ahead and jump right in and get started. All right, so as I said, today I will be speaking on ISA-funded research and how it can benefit farmers. So my hope for my talk today is that you walk away with some new knowledge of Chekhov-funded research. A lot of people don't really know what ISA is funding, and we are really working hard to increase the knowledge out there of where Chekhov-funded dollars are going towards soybean production research specifically. So this is something that our agronomy team is very passionate about. I think you probably caught on to that in Abigail and Stacy's presentation earlier, that research is something that we feel is very important, supporting researchers around the state, but also developing our own on-farm trialing network. And so you got a preview of that on-farm trialing network this morning from Stacy, but I will actually be focusing more on that research that we're funding with external partners, so like university researchers and some other organizations that we collaborate with. And so that's kind of an overview. We're going to dive into hopefully some things that you can walk away with that are useful for you. Again, this is not research that we are doing ourselves, we are funding it. And so I'm going to be highlighting the researchers who are actually doing the work and encourage you to reach out to them specifically if you have in-depth questions. But I will hopefully provide you some overview information that you can use. And I guess just some quick background on myself as well. So I have been with the Illinois Soybean Association for about 2 years now. Prior to that, I did work with University of Illinois Extension on water quality issues down in South Central and Southeastern Illinois, especially around the Illinois nutrient loss reduction strategy. Prior to that, I am a graduate of University of Illinois with a bachelor's in natural resources and environmental sciences, and I have my master's in agronomy from Purdue University. And I did grow up on my family's corn and soybean farm in Hager County, which my parents are actually in the audience today. So it's just nice to grow up on a farm family and to be able to serve farmers in this capacity as an Illinois Soybean Association staff member. So I just appreciate that you're all here today, and we'll go ahead and dive in. Okay, so on this slide, this is a statement that I created myself, and I think it reflects how I feel and how our agronomy staff team feels. So we really think that checkoff dollars should be directed towards soybean production research that will fund studies that will provide new or updated recommendations that will benefit a farm operation or lay groundwork for future studies. So this is practical research. That's what we're trying to fund here. We find that it's really important that there can be takeaways at the end of a study that a farmer can implement onto their operation quickly if possible. And we all know research, sometimes results aren't quickly come by, so it may take a few years to actually get a study completed that can be useful to farmers. But we really value that as a checkoff, that the research that we're doing will be applicable to farmers, or it can lay the groundwork for those future studies. So that's another way that we think of checkoff dollars, is as sort of seed money. So if a researcher has an idea that they want to try out and see in a small plot trial how this might work, they can use checkoff money to do that, but then maybe apply for larger grant opportunities in the future with the results that they found from checkoff funded work. So we just really value supporting researchers in the state, and doing that is one way to help them lay the groundwork for those future studies too. So that's kind of like a personal belief of how we should utilize checkoff dollars, especially for soybean production research. So I think that's something that's very exciting for the association to be heading in that direction, and we hope to continue to grow that program as well. So this was highlighted this morning as well by Stacy. We actually doubled the number of soybean production research projects that were funded this year. So we speak in fiscal years, and so fiscal year 24 began September 1st of 2023 and will run until August 31st of this year, 2024. So this fiscal year, we doubled the amount of projects that were funded for soybean production research specifically. So ISA has multiple different aspects to it. So there's market development, government relations and policy, and agronomy, soybean production. So checkoff dollars are funding many, many things, but this is very exciting to us that we were able to double the amount of projects that were funded. And so I encourage you to pick up this brochure. It is on the table in the main hallway, and this includes the overviews of the different research projects that were funded for fiscal year 24. Some were new. We had 8 new projects, so half were brand new, which was very exciting to engage with new researchers. I also wanted to highlight our new research hub on illsoyadvisor.com. So last year we developed a way to highlight our researchers that we were working with, and this year we kind of took that and revamped it a little bit and refocused on the projects themselves while still highlighting the researchers. So this is something that we are proud of. We want to point people towards this resource because this is where you can learn about what is being done with checkoff funded research in terms of soybean production. So I'm going to quickly, this is just a screenshot of the research hub from my phone. If you scroll through this, and you can see that you can meet the researchers, there's a project archive where you can visit old projects. We have the 3 main categories of projects that we fund. So there I clicked on pest management. What are we funding in pest management? Okay, you're curious, you can scroll through and see the list of projects here that are currently funded in regards to pest management. So if you want to learn more about cover crops and SCN, you click that project to learn more. You can view an overview of the project in PDF form, or you can keep scrolling and see these different drop downs where you can learn about what questions is this project trying to address, where is this research happening, Why is this research important to me? You can learn about the lead researcher who is conducting the project. And often these are done in teams, of course. We know research isn't a solo thing, but we highlight the principal investigator of each project. So Jason Bond, for example, down at Southern Illinois University, is our partner on this project. And so you can do that for all of the projects that we're funding. And this is something we'll continue to build on each year. So I highly encourage you to go to the Research Hub. It's ilsoadvisor.com/research, and you will find all of these excellent projects. And so the topic today is ISA-funded research. What can it do for you? And so I wanted to pull just some highlights of examples of projects. Some have been completed and some are still ongoing. Some have just started this year. So I'm just highlighting 6 projects for you here. And again, like I said, I am not the principal investigator. I'm not the researcher doing these, but I am here to try and help you learn more about these opportunities that are happening that could be useful for you. So this will be kind of like a highlight reel, but feel free to ask questions at the end, and I'm excited to hear your feedback. So the first thing we'll talk about, what can ISA-funded research do? It can change the way you fertilize. It can inform your scouting practices. It can guide your adoption of cover crops. It can shed light on your variety selections. It can help you battle resistant weed populations in your fields. And it can help you extract more value from your crop. So these are the 6 ideas that we're going to cycle through today of how ISA-funded research can help you. So we'll go ahead and dive in. ISA-funded research can change the way you fertilize. Andrew Margonaut is a researcher here at University of Illinois who conducted a 2-year study with us that was completed in 2022. The project title was A Comprehensive Evaluation of Phosphorus Best Management Practices for Soybean to Increase Nutrient Use Efficiency, Profitability, and Water Quality. That's a lot of words, right? So basically he was looking at how can we reevaluate our phosphorus fertilizer management strategies. And so Andrew led a team who conducted the study in Urbana and Ewing, which Ewing is in very south Illinois, so south central. He was looking at 3 different phosphorus sources. So we had MAP, DAP, and TSP, triple superphosphate. And he was looking at 2 different rates, maintenance and 75% of the maintenance rate. And these are rates that are currently recommended in the Illinois Agronomy Handbook. He was also looking at 3 timings and placements, so a fall broadcast, a spring broadcast, and spring banding. And so Andrew was just trying to help understand those current recommendations in the Agronomy Handbook. Are they still accurate for the state? Are there ways that we can improve the amount of fertilizer we're putting out, not only for our own pocket savings, but also for water quality improvements? And so Andrew found from this that looking at those 3 different sources, the rates and 3 timings and placements, that soybean yield and pea removal rates were similar across all of those. So across the source, the rate, the timing, and the placement. It didn't matter between MAP, DAP, and TSP. Soybean yield and pea removal rates were similar, no significant differences. So what he concluded from this was, as a source, triple superphosphate is just as good as MAP or DAP for soybean yield. And it has the added benefit of reducing nitrogen loss. So we know MAP and DAP have a nitrogen component, and especially when you're applying MAP or DAP in the fall, there is a greater chance of losing nitrogen into water. And so TSP does not have that nitrogen component. It's just triple superphosphate, 0,46,0. So if you're going to apply a phosphorus product in the fall, TSP is definitely a great option for you. And if you are going to apply MAP or DAP, consider changing that timing from the fall to the spring. So especially in fall, he did see that there are still significant losses of nitrogen from MAP or DAP, but by doing those applications in the spring, it did minimize nitrogen loss. We have several resources about this project on ilsoadvisor.com. So Andrew completed a webinar for us, a whole hour webinar where you can go hear him talk exactly about this project, what he did, what they found in full detail. We also have a fact sheet online that you can view. I have a screenshot of it on there as well. And so it has the data listed out, the why we did this project, and the findings as well. So you can find that on ilsoadvisor.com/research/archive. And our archive currently, I'll say, only has 2 things on it because we are really ramping up the research that we're doing. And so this is one project that's been completed. Like I said, I've only been on the team for 2 years. So some of the historical work that has been done at ISA is not available on here yet, but could be something we visit. And then as more projects are being funded and completed, keep an eye on that archive because more and more information is going to become available. So next, ISA-funded research can inform your scouting practices. This is Dr. Jason Bond down at Southern Illinois University in Carbondale. He conducted a study called Using Multispectral Platforms to Manage the Soybean Cyst Nematode. So that's a fancy way of saying they were using drones to try and understand if they could use that technology to determine where soybean cyst nematode was causing the most stress in a field, and then create adaptive management strategies based off of those drone findings. So this study just wrapped up. We just got the final report about a month or 2 ago. So it was a 3-year study from 2021 to 2023. And again, he was looking at how to use a drone to estimate those SCN infestation levels. They did this trial in several fields down near Carmi in Southern Illinois. And so what they found was the normalized difference vegetation index, which is NDVI, has shown significant correlations with SCN indicators. So if you use a drone, there are several different of these indexes that can be used. They looked at 19, and NDVI was the one that had the most significant correlation with SCN indicators. So what they're recommending is that using that drone technology, flying and looking at the NDVI can help us detect SCN stress by assessing the soybean canopy at the end of the growing season. So it was interesting because they found they couldn't detect SCN prior to September, but whenever they got to September and beyond, they were able to use that technology to see those indicators of stress from SCN. And so this was one where when we got the final report, we were like, that's super interesting. Now, how can this apply to people? What's the next steps with this? And so Jason's team actually developed a toolkit that can be used with people who have drones. So whether it's your advisor or you as a farmer have a drone yourself, you can receive this toolkit and use it to help you do scouting trips with your drone. And this is something that we're actually going to follow up with Jason and say, okay, now we have this toolkit, can we create a training package for advisors and farmers to utilize this more in depth? Or can we, what are the next steps to really dive into new management strategies utilizing the drone technology? So this is one that is currently wrapped up, but we'll probably have next steps associated with it because we just want to understand now that we have this technology, what else can we do with it? What was cool about this project too was the amount of grad students and postdocs that were involved with it. So that's something else that we're really passionate about here at ISA is student engagement and training up the next leaders in agriculture. So as a team, we are very passionate. Like I said, we have the student research poster competition this evening that I encourage you to stick around for. We really want to help those next leaders become agriculture just staples here in Illinois. We want them to stay, and we want them to help adding to our value here in Illinois ag. And so these two were students that were on this project that learned a lot of new skills, and so we're very excited about that. This project is also in the archive. It's the second project that's currently in there, so I encourage you to go check that out as well if you are wanting to learn more about this project. We actually have a video where you can hear Jason and the students talking about their findings from last year, and so we'll continue to kind of update some of those results as they come out. ISA research can also help guide your adoption of cover crops. So I think you've picked up on our team is passionate about soil health as well. This is one project that we have helped support with Nathan Johanning. He is a commercial ag educator with University of Illinois Extension. And he is based in the Belleville area, but he has utilized several colleagues to help this project have a wider reach across the state of Illinois. So the project title of this one is Understanding the Importance of Cover Crop Planting Day in Illinois Row Crop Production. And Stacy actually mentioned this one earlier as well. This is one we're very excited about because it seems like it might be simple, but there are still so many farmers who have questions about cover crops, like what may seem like simple questions of what seeding rate do I use, what time of year is best for me to maximize my biomass production. And those really aren't simple questions if you've never done it. Those are they can be very confusing and people need guidance. And so Nathan is extremely practical, has great hands-on information, and so this project has been exciting to us. It's currently in its second year, so it started in fall of 2022. He has planted the second year's worth of cover crops this past fall, so he'll be collecting more information this spring and throughout the growing season. But this trial specifically was looking at how to optimize planting windows of cover crops, those seeding rates, termination timings, to really maximize our biomass production and the rotational crop stand and growth and yield. So he is looking at both corn and soybean, which that's another big thing that we are proponents of. As a Soybean Association, we understand that corn is extremely popular as well. So corn and soybeans are in rotation in Illinois, and we support both of those crops. And so we want to be able to support our growers who are soybean and corn growers to adopt cover crops and understand how to best fit them into their rotation. So that's another benefit of this project. I remember when Nathan came to us, he's like, "Can I look at corn too?" And we're like, "Yes." Just because we're the Soybean Association doesn't mean you can't study corn. We really encourage it. So this one, he's looking at 5 different sites. So we have the Monmouth University of Illinois site, the Orr Center here, Urbana on the South Farms, Belleville, and then Ewing again. And so this past fall, he planted 4 different cereal rye rates, so looking at 30, 60, 90, and 120 pounds at 3 different planting dates, September 29th, October 19th, and November 22nd, and that's all going to be cereal rye before soybean. He also is looking at 3 different clover planting dates for both crimson clover and balanza clover. So those 3 planting dates were October 19th, November 6th, and November 22nd. We only have 1 year worth of data from this project so far. Like I said, we're in year 2. So we are hesitant to give full guidelines or recommendations based off of 1 year of data. But Nathan has come back with some just general thoughts and observations. So again, Nathan is very excellent at practical hands-on information. And so one thing that he has shared with us so far is that those earlier cover crop planting dates really can provide great biomass and more reliable cover crop establishment for both the clovers and the cereal rye. So it seems obvious, yes, if you plant something earlier, you're probably going to have better biomass growth. But he is finding that even at that 30-pound rate, that lowest rate that he's looking at, planting it earlier really helps establish the stand so that it has the potential to grow into the fall and then really rebound again in the spring, especially with cereal rye. So just because you might not want to do 120 pounds, that's a lot. You may not want to put out that much, but putting out 30 pounds at that earlier date really can help maximize your growth. But also another observation was that November 22nd date, a lot of times people get done with harvest and think, oh, it's too late to get a good stand. But Nathan's finding that to the contrary, you still can get a good stand in the fall established, even at November 22nd. And just getting it established in the fall, even if you have a couple inches of growth, that's going to allow the cereal rye or clovers to take off in the spring whenever they overwinter and come back. So this is evolving. Like I said, we'll have another year's worth of data after this spring, and I encourage you to stay tuned to ILSOY Advisor. But if you actually want to hear from Nathan, he provided 2 updates for us in December where he was at the Belleville research site and walked through each plot. It's really great information. If you're just curious, what does 120 pounds of cereal rye planted in November look like a month later? Nathan really gets down on his hands and knees and looks at the clover and everything. So I encourage you, these are just like 6 or 7 minute videos on the Illinois Soybean Association YouTube channel. So go check those out. This is the kind of information that we're trying to promote. We want that hands-on information where a farmer can see and take back to their own operation. All right, what else can ISA-funded research do for you? It can provide insights into your variety selections. So some of you may know that we support the University of Illinois crop science variety trials. For the soybean side, we have supported the protein and oil content measurements for the past several years. This is operated through Darren Juice, so he's here on campus as a research agronomist, and he is the one who goes around throughout all the state and harvests the variety trials and is very busy in spring and fall getting these variety trials out there. And him and his team do an excellent job doing that. And we appreciate that because this is wonderful, unbiased information on both corn, soybean, and wheat varieties that is available every year to growers. And so as the Soybean Association, we are happy to be able to support that through the protein and oil content testing. They are trying to always continue to streamline that data collection so that it can be compiled and made available to farmers more quickly so that you can really utilize it when you're making your variety selections. So if you haven't checked it out before, the website's here. If you just Google variety testing UIUC, it'll pop right up. And this is a great resource that really needs our support because some companies have been kind of pulling back from this variety testing, putting their varieties into the trial. And for us, we are very supportive of unbiased information, and we know that companies have their own agenda at times, and so having the university providing these results for us through the variety testing is extremely important. So we encourage you, if you're working with a dealer, say, hey, have you submitted this to the variety trialing? We'd love to see it in there. Just so that we can continue to support this data collection. So new this year, we are adding soybean cyst nematode testing as well. And so Nathan Schroeder is a professor here on campus as well who is partnering with Darren Juice to be able to look at how do these different soybean varieties fare under different SCN pressures at all the different testing sites. How can these different varieties with the same genetic resistance respond to SCN pressures and what causes those differences in responses? And then how do the varieties respond to differences between SCN populations? So this was great for us as well. If you haven't heard, the Soybean Association is also sponsoring free soybean cyst nematode sampling this year. So I encourage you to utilize that resource. You can send in as many soil samples as you want to the plant clinic here at University of Illinois, and they will sample them for you for free. And that's something that the Soybean Association is providing back to growers and advisors this year. And so that data will also help feed into the variety selections, and this is all kind of compiling onto each other where we're trying to grow our efforts around soybean cyst nematode. And so if you aren't familiar with the variety trialing, they do conduct this in multiple locations around the state. So we have Freeport and DeKalb in Region 1, Monmouth and Goodfield in Region 2, Perry and Urbana in Region 3, and St. Peter and Belleville in Region 4. So again, if you go on to that website, you can see data from the past several years for these research sites. ISA research can also help you battle resistant weed populations in your fields. This is a new study for us this year with Dr. Aaron Hager here at University of Illinois. He is the extension weed scientist, and he is looking at water hemp. We know it's developing resistance to group 15 herbicides, so that's products like Dual 2 Magnum, Zidua, Warrant, and Outlook. And so he's trying to help farmers understand how those resistance levels are developing in populations across Illinois, what level is that present at, and he's going to be coming up with some management strategies to try and help farmers battle the water hemp resistance. And so this was another very exciting project for us. We know that's one of the comments we get the most is just weed management. That's a concern for everyone. How can we help battle these weeds? So this project was exciting, and their team collected water hemp seeds from approximately 120 fields this fall. So if you can imagine that going out, the grad student who is doing that project is actually here today. I don't think he's in the room, but I can't imagine being the one to go out and collect all those water hemp samples. But they did, and they hit approximately 90% of the counties in Illinois. So we'll get a good look at that resistant population across the state. This is actually the grad student here. His name is Travis, and this was a video that FarmDoc put out where they were asking for farmers and advisors to actually submit water hemp samples to them as well. So the team went out and collected samples all around the state, but they also wanted farmers to submit their own samples just to broaden the amount of impact and reach that the project had. And so Travis here put together a great video kind of instructing farmers on how they could collect their water hemp samples and send them in to the lab. And This map here is the sample collection that they hit. So the counties in green are counties that were sampled by the lab, Aaron's lab in Travis at University of Illinois. And the light green squares are ones that farmers submitted samples from, and the UIUC team also went to those counties. So you can see there's not as many light green counties as dark green. So we had 10 counties that received submissions from farmers and advisors, and Aaron Hager's team captured 84 counties themselves. So this was something where Travis reached out, asked for help to get samples submitted. We shared this information on our website as well, really wanting to engage farmers and advisors to contribute to this project. And 10 counties is great, but we hope if they do this again next year, which they are planning to, that we could get even more than 10. So this was pretty simple. They even covered the shipping, I believe. You just had to go out to the field and cut your sample and ship it in a paper bag. And so this is something we really want to engage more growers with our research. It's important to you. These findings are extremely relevant, and so we want to make sure that the checkoff dollars are being utilized to the best of their ability. And so if you're interested in doing things like this, we highly encourage you to take advantage of opportunities where researchers are asking for that engagement from you. Sometimes that doesn't always happen, where researchers might be more isolated in their lab, and this is not a program like that. They are very engaged, and so just encourage you to engage back with them if you feel like it and have the chance. All right, ISA research can also help you extract more value from your crop. So some of you may be familiar with the soyleic soybean varieties. I want to introduce Dr. Eliana Monteverde. She's in the room, actually. She is the new plant breeder here at University of Illinois, and she has replaced Dr. Brian Deers, which many of us were familiar with. Dr. Deers had a long career, wonderful career here at University of Illinois, and he retired last spring, and so we're very happy that Eliana was able to fill his position. And so Dr. Deers really began this work here in Illinois with soyleic, and so soyleic was a project out of University of Missouri. So they were looking at developing a soybean, a variety that has the greater than 80% oleic acid and less than 3% linolenic acid. And so this is all kind of going back to health concerns over soybean oil. So the trans fat in traditional soybean varieties is really high. And so when people use that as oil for cooking or for different food products, it's been concerning to folks because of the trans fat values. And so the soyleic varieties are being bred in order to have those lower trans fat values and higher values of the healthier fats. So this is a great product that is being developed here in Illinois in collaboration with Missouri and other states to help further the market for soybean growers. And so by breeding these lines and having them come out of Illinois, it's just very exciting to have a new space, a new variety for farmers to help grow into. So it is a non-GMO variety, and so this is also something that as a soybean association, we want to help support growers as they're looking into non-GMO varieties. How can I best grow those whenever there are concerns like weed management, especially, and just all the different aspects that go into growing non-GMO. But yes, so soyleic ISA checkoff funding specifically will be helping expand just the testing that they're able to do with that program here in Illinois. It was already happening, and like I said, many thanks to Dr. Deers for starting this and for Dr. Eliana Monteverde to continue that work as she's new here in the state. But we look forward to continuing to work with Eliana and the new projects that she might have passion about as well. Yes, and so getting back to farmer and advisor participation. So I touched on this with Dr. Aaron Hager's project, where there was an opportunity to farmers for them to submit samples into that program to have them assessed for resistance to group 15 herbicides. But that was not the only opportunity that we had available for farmer participation this year. And so this is a screenshot of our homepage on the illsoyadvisor.com, where it says free farmer-led soybean data collection, a win-win for farmers and researchers. And so we really believe that whenever researchers invite farmers to submit samples, It's a free exchange of knowledge and resources. You have a problem, the researcher's trying to help you. It only makes sense for the farmers and researchers to interact in that way and submit samples, talk to each other, kind of like what Chris was saying in his keynote this morning. Use your resources, and we have a lot of new talent coming into Illinois in terms of researchers, and we want to support that and the work that they're doing. So this screenshot, if you go to this drop down and click surveys there under tools and resources, you can see here I mentioned we have the free soybean cyst nematode program going on this year. So that is one way that you could help collect soil samples that will benefit you, but also researchers will take that information to understand soybean cyst nematode resistant populations around the state. If you keep scrolling, you'll see we had several other opportunities for farmer engagement. That annual soybean quality survey was one from Minnesota that they were doing Midwest, across the Midwest. This was one from Dr. Nick Sider here at University of Illinois. He was looking for Dectes stem borer samples to be submitted, or for farmers to walk their own fields and assess those populations there. And there's also the water hemp survey, and just putting this out there that we are trying to encourage that engagement between researchers and farmers, and this resource is available on illsoyadvisor.com for you to learn about those opportunities. We also share about them at events like today or throughout social media, so as these new opportunities pop up, we will share about them. And you know, like I said, it's free. The researchers often will provide shipping costs because they know their funders want that shipping to be free for the grower. So it's really just your time and maybe a little bit of energy to collect the sample, but it can really help you and also just growers all throughout Illinois. And speaking of that, this was mentioned earlier as well by Stacy, but I really just wanted to hit it again. That we at ISA conduct an annual soybean production concerns survey. And this is something that we target towards farmers and advisors to help us understand what your concerns are in the field. Because we are the Checkoff Association. You give money to the Checkoff Association. And maybe give is not a term I should use. You may not choose to, but we get money from your soybean crop, and we want to use it to benefit you. And that is extremely important to us because we work for you, the farmer. And so we need you to tell us what you want us to study. So we are able to help curate the research projects that are done with Checkoff-funded research as the ISA staff. But we can't do that without your help. So I highly encourage you to take this survey. It's in your booklet as well. There's a QR code that you could scan on your device to take that. Scan the code here. It lives on our ILSOY Advisor website now. If you go to that research hub, you can find this survey. Please take it, because you are able to steer the direction of Checkoff-funded research by taking this survey. Otherwise, we're going to do our best to try and figure out what your concerns are, and we do know because we're in the field as well, but to an extent, like, we want to make sure that we're hitting the things that you really want researched with Checkoff dollars. So again, I just ask that you take this. It'll be open year-round. This is new. We used to close it after this event, actually. We just would keep it open for about a month in January, but we realized really things might come to your mind in the middle of the growing season whenever you're out scouting your fields, or and when you're in the combine and harvest, something might come to mind like, oh, I wish someone would research this topic more. Come take the survey. It'll be on illsoyadvisor.com year-round. And so just encourage you to do that. And we also encourage you to talk to us anytime. Please talk to the staff on the agronomy team especially, because we take that feedback very seriously, what you're telling us that you want funded, because we want to be able to produce things that are useful to you, that only makes sense, right? We want to maximize that checkoff dollar to your benefit as much as we can. So with that, I'm going to say thank you for joining today, and I'm happy to take any questions. I think we have about 5 minutes, but yeah, just again, thank you for participating in today. We're just glad to have you here, and yeah, happy to take any questions.
You were talking about the soybean cyst nematode testing program, and I had some signs of that last year and took several samples, and I had one field that really had a pretty high cyst nematode count. So when I went to buy seed beans for this coming year, I indicated that to my dealer, and he was talking about the lack of resistant varieties, and that we've got the Peking and another number, and almost all of our resistance comes from those two. Are we, the soybean industry or Illinois soybean, pushing the development of some other resistant variety that can be bred into these, because those two seem to be maxed out and not performing, and my dealer just said he was surprised that the industry in general wasn't developing more cyst nematode resistance, because it seems to be the number one problem we have in the soybean industry. And I just wondered if there's research on some level to come up with another resistant variety that can be bred into these new genetics.
Yeah, good question, Don. Thank you. So from that free soybean cyst nematode sampling that we're doing, Nathan Schroeder here at University of Illinois is actually going to be compiling the data for us, and any fields that had over 3,000 SC and egg counts from those samples, they're going to do an additional test to look at what is called an HD type test to understand which of those varieties that the soybean cyst nematode population in that specific field are resistant to. And so we're going to take that information to have a better understanding of, yes, the resistance all around the state, but then also hopefully we can take that information to help guide researchers towards potential new forms of resistance in the varieties. So are we funding that specifically right now? In a way, yeah, through the SDN sampling. We hope we can help provide information to contribute to the issue. I think it's a very large scale issue, so Illinois Soybean Association isn't going to be able to answer that question ourselves, but hopefully the data that we're collecting can be supportive to our industry partners. It's not something we're going to keep closed-chested to us. We're hoping to share that data back out, because currently, the last update we had, they had received, I think, 560 samples to that SCN sampling, and it was 48 counties, but we really hope we can get samples from every county in Illinois towards that SCN sampling. So if you haven't submitted a sample, please do. It's free, again, and they'll send you a package where you can ship in your samples to the plant clinic. But we really want to try and capture as many samples as we can to help that data set be more robust, so that we can understand the resistance around the state, and then, yeah, help the researchers use that data to address that problem. Thank you. Any other questions?
When's it a good time to test for your cyst nematodes and yes,
Yeah.
testing questions?
Yeah, fall was great, spring will be great as well, and it goes throughout the growing season, so through August 31st of this year is when you can submit the samples, so really anytime before then, probably not when the ground's frozen, that wouldn't be a great time, or if it's extremely muddy, I wouldn't suggest that either, but yeah, the springtime will be probably your next best bet to get out and do it, but you'll have through August 31st to go ahead and submit that. And you can submit as many samples as you want from as many fields as you want. There isn't a limit, so. Thank you. All right. Thank you so much. All right, and quick closing, if you're a CCA, please don't forget that you can claim those credits in the main hallway. There will be a table with a QR code that you can scan to gain credits for that. And thank you for those online. You will need to read the CEU instructions that are in the chat. And so the next session will begin at 2 o'clock. If you want to shift rooms or stay here, you're welcome to, and go get a snack, and we'll start again at 2 o'clock. Thank you.
Introduce myself. I'm Clay Harper. I'm actually Darren Joseph's replacement in the variety testing program.
Awesome. Nice to meet you. Yes.
Yes.
Thank you very much. Are you the next person? Yes. Let's come this way. Oh yeah, get your PowerPoint first. Okay. How you doing today? Good. All right, I'm gonna put this on you, and if you just pull this out, I'm gonna put it right in here. Now we're gonna tuck it under
around the back.
collar a little bit.
Perfect.
See in your front pocket.
Yep.
Why don't you put that in there?
Yep. Like that.
How's that feel? Let me make sure.
It's all right. I can be loud too.
That's fine. I will adjust it. Now we may do a couple other tests here because the people on the live stream were saying there is an echo in this room. So quick little housekeeping. Right now, you can talk to everybody in the
Anybody?
room right here, right now, or whatever.
You control me from the back.
Well, I'm gonna go to it. When you're ready, if you ever want to say anything to people on the
Check,
stream,
check.
get a hold of me. I'll talk
1,
out
2.
loud, and then you'll be
1,
able to
2,
talk.
check.
So the first thing I'm going to do is I'm going to start on this screen, so all the viewers get to see. Blah, 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 blah. Then I'll come to you, and then when you change the slide, I'm going back to the slides and staying.
Yep, and I'll warn you. I've got a lot of slides, so they'll move fast. So probably best if it just stays.
Yep, I wanted to see your face a little bit.
Yep,
So I wanted
perfect.
to see you at the beginning.
Yep. Yep, appreciate it.
Check, check. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3.
Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Go backwards now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 1, 2. Check, check. Start doing my opera, singing. You need me to keep talking? I can keep talking. They got me for 45 minutes. Good practice. No worries. Now, went through this. I did a high school theater, so different setups. Although usually then you had lines that you could just start reciting and keep going. But you want me to keep talking? campus lost all internet on Monday, so. Keep speaking? All right, yep, I can keep talking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Soybeans, talking high soybean yields today, fertilizers, fungicide, insecticide, yields. My name is Connor Sible, postdoc. I'll get louder too as on the stage.
One, two, three, four.
I'm gonna throw this at you when he's standing on the stage. There's a speaker directly over the podium.
1, 2, 3, 4.
And I'll wander
1,
too.
2, 3, 4.
I will probably go back and forth across the stage too.
Check, check.
It's very wide. Yep.
All right, good afternoon. We're going to go ahead and get started if you want to find your seat, and welcome to our online participants as well. All right, welcome to the second session in the Research Breakout Room at Soybean Summit. My name is Jennifer Jones. I'm the research agronomist here for the Illinois Soybean Association, and happy to see you all today. I'm pleased to introduce this session's speaker, Dr. Connor Sible from the University of Illinois here in Urbana-Champaign. Dr. Sible's interests are in high-yield corn and soybean production systems with a range of different approaches. Prior to starting a postdoc, his previous research focused on categorizing biological products and in understanding where, how, and why they work to improve fertilizer use efficiency and increase crop yields. Dr. Sible's current research still touches these topics, but has added a focus on crop residue management and genetic by management interactions. So today, Dr. Sible will discuss the latest findings from the University of Illinois Crop Physiology Lab related to soybean planting dates, cover crops and double crop management, and optimizing fertilizer use efficiency to bring yield and ROI to soybean production. Before Dr. Sible comes up, just as a reminder, if you have questions during the Q&A period, please use the microphone to ask your questions so those online can hear it as well. Thank you, and I'll invite Dr. Sible up to the stage.
All right, good afternoon. Well, that was great, first try. You guys are ready to go. All right. We really appreciate the opportunity to be here and to talk about soybean success. And we'll get into why, no longer a secret, because I think many of you that may not know who I am probably know who I work with. And that's Dr. Fred Below. I did all my grad work with Dr. Below, and in the very last year of my PhD, decided I want to try academia rather than industry. And apparently there's a different route of training to be a professor versus an industry agronomist. And so I am now what is called a postdoc. We're about a month after the holidays, and I just got done telling all my family and explaining to them what a postdoc is. Right? So they're like, oh, you've graduated, so you're teaching now? Nope. But you don't take classes, you're not a student? Nope. And then there's an awkward pause, and they're like, so what do you do? Right? And so postdoc is a lot of research. But the way I kind of say it's professor in training. So eventually someday I do hope to be an extension specialist at some university working in row crop production. And my master's and PhD work was all focused on this biological biostimulant market. It's a booming bust. We can talk about that another day. But what I'm really excited about in my postdoc role, I've been able to expand and look at some more broader topics. And today I'm going to bring you some of the things about soybean. And specifically, I'm not going to give you anything that's just, wow, brand new, out of the blue. A lot of what we're going to talk about is things you've probably already know. But things that are good reminders. Why are we doing these things? And what are we seeing in recent years to continue building upon those and making sure the practices we implement are indeed a success and not a random luck of the draw secret. So I kind of want to start with a question. Is soybean currently managed adequately? Or if we rephrase the question, are we achieving full yield potential? See, if you're shaking heads, you know where this is going, right? So what is full yield potential, right? And what might be the world recognized, right? There's studies out there that do theoretical yields. What a soybean or corn plant could produce theoretically, but we live in the real world where we have to put them out in the environment and into soils, and there's a realized yield goal. And so that would be the world soybean record, and then the soybean yield gap would be the difference between the record and the average, right? And so when we look at the soybean yield gap, the world record actually is now 207 bushels per acre. And that came out of Georgia, right? Actually, a lot of our high record corn soybean yields come from the East Coast. So why not the I-states for these records? Well, sometimes, we blame things like clouds and such, but the other thing you have to remember, they're on some sandy soils where any nutrition they put out either goes up into the crop or down through the system. So a little different there on fertility management that helps them. They're also on the coastline. That cool ocean breeze has a big influence on the end of season grain development and some other factors. But that's the world record, right? So that's the potential that has been realized today. While the U.S. average is about 52 bushels, that was in 2016. I don't think the U.S. average has gone above that across the state. Illinois, number one. And if you look at the records, we did get 65 bushels on average across the state in 2021, right? But if you do the difference between the maximum and the average, That's 155 bushels. That's the yield gap. Now, I truly don't think we're going to get the average to 207. But the gap is currently 3 times our current average. That, to me, is something we can change. If we can get the average equal to the gap, that's significant progress, and that'll bring some real value to the farm and to our fields. So how do we get there? You know, I started out as an engineer. For those that don't know my background, my freshman year I was going to be ag engineer and work on combines for John Deere, right? That's a lot of math and a lot of computer and computing, and I learned that real fast and jumped to biology in the spring semester. And then I found out there's math and biology too, but it's not quite as hard, right? So we do have algorithms, and so here's the soybean yield algorithm. It's pod number per acre, right? It's not plants per acre. Darn things branch. And so it's pod number per acre. Seeds per pod, weight per seed. Seems pretty simple, doesn't it? When we think about these, what can we control over? Seeds per pod, right? If you're really high management, you might be able to get that a little higher, but that's largely genetically constrained. So what we can control is pod number per acre and weight per seed. And when you think about pod number per acre, that's the first half of the season. Weight per seed is the second half of the season. Rule number 1 for successful soybean yield, season-long management. If you start out strong, don't give up or think, it's going to do fine the rest of the way. I gave it the start it needed. I'm going to go on vacation. True high yield is a season-long commitment. If you set the pod number, now you got to make sure you fill them, because if you have more mouths to feed, that's more food input to feed them if you want them all to be the same level of full. We went back, and Marcos Lohman, he's not here right now, he's a grad student in our lab, and he looked at a lot of our untreated control data over time and just looked at these yield components to yield. And so this is a massive correlation, pretty tight. You know, there's almost 1,300 different data points on this. And what you can see is that grain yield of soybean changes linearly, positively, with seed number. So if we're seeing higher yields, it's probably because you have more pods or nodes, and those nodes have pods, right? You saw some fantastic photos, and those beans were just loaded with pods. And then the second half is the seed weight. And you'll see that it's kind of correlated to yield, but really it's seed number. So most of our management is ensuring we grow a solid soybean plant that puts on the nodes and the pods. And here's the hardest part to it all. You got to keep those pods. Soybean is lazy, and it will set a very high number of pods and say, all right, I gave myself the potential, but I'm a low achiever. I can cut half of those away and still be fine. Biology reproduce, right? So seed number more than seed weight drives yield. So how do we manage these factors? And that's where we have the 6 secrets of soybean success, right? These are the factors that can have the biggest impact on yield. And anyone that's heard Dr. Bilo speak, you've heard this before, right? We're beating this puppy to death, but it works. And guess what? This was put out in 2012. And when I've been thinking about the last 12 years, or 11 seasons, now going into our 12th year, 2024, it's the same factors. So the factors themselves have not changed. And the cool thing about this is there's nothing on this list that is really out of reach for all of our acres, except maybe this last one, the row spacing on here. We brought that down a little bit on this list because we can see that a lot of these other ones are a little more easier to manage. No equipment change on that. And then here's just a different variety photo. So what we're going to kind of do is just a review, right? 2012 is when Dr. Bilo put these out, and we've kind of revamped it with what we know now. And that's what I want to do today, is go through our updated findings the last 2 to 3 seasons that are more relevant to today's genetics and weather. And you can actually see if we reorder these for today, row spacing has gone up on our list a little bit. They shuffle. So the first thing I'm going to put there is the weather. We estimate about 35 bushel of difference or not. That was, on the farmer panel. What's the one thing? Control the controllables that we discussed. Can't control the weather, right? I wish we could. But weather is more, when people ask, why is planting date not on here? Because it's controlled by the weather. So you can kind of lump planting date and weather together. And it's been a hot topic, right? And I think if you follow the report, the general consensus is plant early. There's been enough studies, enough people doing that, myself included, to see that advantage. And we're going to talk about that. But what we want to talk about now, okay, if you're planting in April today, but 4 years ago we're planting in late May after corn, should you manage your April soybeans the exact same way you manage the May soybean? And our hypothesis was probably not. So understanding now that we've changed how we plant, we probably have to change how we manage. So, this is just an example. 2019 Champaign, May 15th, not a single plot went in the ground for us. Planting dates were late. I think our first corn trial went in the ground May 30th. It was a brutal planting season for us on the research side. I think we put all our plots out in the first 2 weeks of June for the most part. But one of our former students went back and looked at all our control yields over time and the date they were planted and plotted that on a chart. And so here they are. You can see the different years that those different control yields came from, and then the Julian day or the respective day of the year on the bottom axis. And you do a simple regression on this, and you more or less get about a loss of a half a bushel per acre per day for every day after April 23rd. Now, why April 23rd? Because when he put this data set together, we had never planted earlier than that in our research program. And we just assume that line probably keeps going. We're going to talk about that moving forward. But this really opened our eyes. And so to go after this, we developed a trial, started last season, or 2 seasons ago, 2022, into 2023, that starts with planting date and then all the other factors we can think about to manage with that. Here's an example. In the background, you can see we had different blocks. So here's our early planted starting to mature, and then our late planted, they're a little bit behind. So in 2022, here's a graph of the percentage of soybean acres planted over time for the state of Illinois. And you can see, we were about, 50% third week of May. So either first half of May or after May for soybean. And what's going on in this phase right here, up in this white space? Probably planting your corn, right? So the corn graph is the inverse. Corn acres, really start high if you think about it, and then it comes together. And so we did a first planting date that year was late April. And then we came back early May, late May, and June. So this is where our planting dates stacked up respective to the rest of the state. And specifically for us, those dates that in 2022 were April 23rd, right? Coincidentally, the same date that was on that regression graph, just happened to be the first day we could get in the field that year. May 9th, 31st, June 15th, and then a bunch of different managements within this, and we duplicated this on the other side. And I'm going to skip a little bit of the in-season and just jump right to what everyone always likes to see, right? What were the yields? And pretty straightforward. As you planted earlier, you got more yield. Actually, April 23rd to June 15th was a 20 bushel yield difference. Now, this is the part that I said a lot of us are starting to realize the potential's there, but what's going on in the background, right? I've got physiology on my shirt. So where is the yield coming from, and why did I start off with our soybean yield algorithm? When you look at these photos, right, here's the different planting dates, April 23rd versus May 9th. That's taken on June 15th. That's the date that the 4th planting date went in the ground. And here's May 9th versus May 31st, and then May 31st versus June 15th, right, just went in. Now, you want to be over here on June 15th, or would you like to see your beans over here? And what's going on as this develops through the season, right? What's really interesting, the April 23rd, May 9th were almost indistinguishable by July 31st, right, well into R3 onto these two planting dates. Huge difference, though, just from May 9th to May 31st. And then look at where our June soybean were. The other thing we were was dry. The emergence on that June planting date was all over the board. I had some V4 beans and some just coming out of the ground because the rain finally came to get them out. So understanding planting depth and making sure those beans get into moisture. We learned that lesson by using a uniform planting date or depth across this study in 2023, I changed that planting date as that, or the depth as the date changed. But just some visuals, but when you really peel it back, you can see the individual plants and you remove the leaves, it tells the story. All right, so on July 31st, that first planting date had 21 nodes. Then I had 20 nodes, 17 nodes, and 12 nodes. Now the good news is these two down here on the end, they keep growing. So they didn't stop at 12 nodes, but at July 31st, right, what do we always say? Beans are made in August. Going into August, I'd rather have 20 nodes on the plant than 12 and not be trying to play catch up. Then you do the math. We planted these at 140,000 plants per acre. And so the total nodes now are 2.9 million nodes, 2.8, 2.4, and 1.7. And then you compare the difference of the April to the June, and I would have needed to have 245,000 plants per acre here to have the same number of nodes. So soybean yield and seed number is not necessarily how many plants you have out there, it's how many nodes per acre that you're working with. And these were main stem nodes. We did not count branch nodes in this, so that probably makes it even different. But this is why soybean yield, driven by seed number, and then once you've got them, you have to then look at managing for seed weight. Comes back to this equation and where we go. And then this is just, happily, a little bit before my time. We probably need to update these numbers, but grad students love to do fun, boring, meticulous tasks, right? Nothing a grad student loves to do more than start counting nodes on soybean. Maybe root digging corn, right? Maybe that's a little bit on their priority list. But when you count, you can see the node number on the bottom and the number of pods per node, and where we sit there in the peak is in the middle of the plant. So most of our yield is in the middle nodes of the plant. So when we think about going from 50 bushels to 60 or 70, where are we going to add the pods? They're going to be at the top of the plant or the bottom of the plant? Right, where do we have more room? Spoiler alert, when we counted those, they're still in the middle. Right? Maybe we move a little bit, one node north and one node south, but the bulk of soybean yield is in the middle. And actually at 140,000 plants per acre, one more pod per plant is just 2 more bushels. Seems easy, right? All you got to do is get every plant out there to put on 1 more pod, and you get 2 bushel advantage. Easier said than done. But this is why seed number is driving yield, and we have to manage for that. One way to do that is planting date. So we did it again in 2023, though, right? Like anything in research, one time's not good enough. You got to repeat, be sure, consistent. So here's the percentage of soybean planting in 2023, and the thing you'll note, we hit 50% here before May 10th. Well ahead of 2022. I've been working with Dr. Bilo for 7 years. Best planting conditions I've ever had to work with. Seed beds were beautiful. That crop was off to a great start. So our first date was actually April 12th was the first date we went this year. We beat last year by 11 days. Then we came in May 4th, May 23rd, and June 14th. So pretty good spread, though, across the 2 years. So how did it yield in 2023? And sure enough, earlier planting, higher yield. And some of you that have better eyesight, right, you caught right away, I'm hiding something from you. Right, so is early planting always a guarantee for higher yields? Sadly, it wasn't in this case for us. A lot of different things going into that. We're still looking into yield components ourselves, processing those over the winter to figure out what happened to lose it. But the key thing here is, May 4th, that's still pretty early considering a lot of people are still focused on corn at this point. But what's going on here? And I don't know if anyone else probably ran into the same problems I did. I've never seen this in a couple years. That's me going out 13% beans, 10% by the end of the day. There's a lot of green there. And this is what we had. Those pods were dry. Actually, some of them, we waited as long as we could, but the pods started to open up, and then you're just losing beans, so you have to try, and we did. And so a couple factors probably here mitigating it. When we go in too early, do we get off to a good start, the drought hits and it crashes harder? What I think we have a source sink issue. We set a high potential with the early, but something in the season, the drought or the conditions at planting when we went that early, meant we didn't have the sink, but we had all that nitrogen in the leaves, had nowhere to go, green stem. Big issue for us on this planting date, and that's what we lost. But the key thing for the last 2 years that we've learned is that the earliest planting may not always win, but the potential it can bring with relative little risk is worth the try, because we still pulled 73 bushel beans. That's still a pretty good day. Now last year it was, I think, 78, 79, but 70, north of 70, and then we can get the advantage. I think there's some work being done now. A little bit later planted corn is not the worst thing. As long as your RM isn't too high and you get frost killed, there's advantage to having corn grain fill with cooler nights if you push that a little further into fall. And so maybe there's a dual potential here. You gain some yield by the beans going earlier, and maybe you gain a few bushels on the corn going a little later because you've pushed their grain fill into a little bit cooler nights. Hot nights on grain fill for corn just eats yield away. So this is what we're starting to see in our research here. These are all done in Champaign and campus. So local planting date data for you. And one of the things that I kind of, it's February 1st, right? So what's tomorrow? Groundhog Day, right? February 2nd, right? We're about to know how much more winter we have. And that's the traditional question, right? So when we talked to Mr. Bill Murray, he's wondering to know how many more weeks of winter do we have? But I'm getting excited about some of the other ways we could rephrase this question. Maybe this is not the question we need to be asking. Maybe when we talk to Phil here, it should be something like this. Soybean goes in the ground early this year. Is the groundhog going to determine not more weeks of winter, but how soon till you better have that planter ready to roll? Just something to go from there, some things that we're excited about, but understanding it's not always a guaranteed win. So that's weather, the planting date, and some other things going on. But the thing that I mentioned, based on April or June, how do you manage that crop? How do you maximize the profitability of the inputs you could put in? Genetics and variety, 25 bushels. So I'm going to show you a trial from 2021 where we had 26 varieties, and this is just standard management. 30-inch row, plant them, walk away, right? Make sure there's no weed pressure. And here's the different 26 varieties going from 1 to 26, highest yield on the top left, lowest yield on the bottom right. Now I'm still happy at 73 bushels, right? But if I had selected a different variety, it could have been just over 100. And that is a 27.6 bushel range, purely by variety selection. Now, to protect the innocent, I'm not going to tell you who's at the top and who's at the bottom, but there is a pretty consistent trend we see with how do you more so lean towards being in this first column with your variety selection than your last column. And we're going to do a little bit of more of a regression, and I'm going to take the yields of those planting dates and break them out by maturity group. So in these planting dates, both years, we had 16 different varieties that ranged from a 2.7 to a 4.2, or I think we may have had a 4.4 in that first year. Quite a big maturity group spread for one location. And so in the regression here, this is what it looked like for the April. And I can tell you that this out here is a little bit of an outlier. That bean was a 2.7, it matured fast. We couldn't get the combine in fast enough. We had pods cracking open. But there's a pretty clear trend. As the maturity group gets longer, the yields go up. If you look at this regression, that number in front of the X would claim 14 bushels for every increase in one maturity group. Now again, like I said, that's biased by this a little bit. But when we look at May 9th, right now it's about 10 bushels. May 31st, it's about 3 bushels for every increase in maturity group, and then we're 4 bushels. So maybe there's a point where it maxes out. But the key point, even if you remove these 2 points here, the longer maturity group for the given planting date tends to be higher yielding. And on those 26 varieties, I can tell you, the high 3s and low 4s were in the first column, and the low 3s and high 2s were in that last column. Huge advantage. So in this year, on average, every one increase in maturity group was worth 8 bushels. So what did that look like in 2023? In this case, we're just going to put all the data points into one regression and put the line through the middle, and you can see you've got the bottom planting date, the middle one, they're color-coded. So our second planting date is in the orange there up on the top. And when you look at this one, and you look at that number up there, it's not as strong, but again, the same trend. One increase in maturity group was worth 4 bushels, 2023. That's a difference from planting a 3.0 versus a 4.0 on the same day. So in general, if you're thinking about variety selection, longer maturity group, don't be afraid to push it a little bit. Now, I know there's situations where you might need an early bean, so you can, one, start harvest a little early, get some acres going, get the combine, make sure it's all ready to go. If you're cover cropping, there's an advantage to getting some of those beans out earlier to get a cover crop. So I understand that every situation is there, but in general, if you're used to a 3.3, why not try 3.5s? If you're used to 3.5s, why not try a 3.7 or a 3.8? And if that one change might give you 2 bushels increase, that's a positive gain without having to change much on the farm. Next, we're going to jump into row spacing a little bit, right? We put 9 bushels on there. We know this changes year to year. When we're planting earlier, we don't see as big of an advantage. But I'm going to summarize. It's going back a little bit, right? So 30-inch rows and 20-inch rows. You can just see canopy closure. A little more elbow room within the row. And we did a lot of trials on this, so I'm going to take us back a little bit, but it's the average of 11 trials from 2014, 2015. That's why I like this data set, because it's the average of 11, and we got a quite good consistent response. And so here we have 30-inch row on top, narrow row, 20 inches for us. We do 20s because of research equipment. We assume 20-inch would be similar to a 15-inch row. And you can see we had a 6 bushel advantage in these trials. Seed number. Give the beans a little more elbow room. They tend to branch a little bit more. Put a few more pods on. So row spacing is helping you get seed number. And then things like foliar protection help fill those seeds seed weight. So we really like row spacing, but we understand the equipment constraints. So it's not like that's the only thing you have to do to get more yields. That's why we kind of started with just planting date and maturity group. Some simple things anyone can do on any acre. We are going to talk about foliar protection. And one thing I'm going to say right off the bat, I'm in the high yield game. I understand there are IPM discussions we have to have as well, disease pressure, thresholds, right? If we overuse these things, we get into resistance, and then they're no longer an effective tool. But one of the challenges on the yield side with fungicide is whether there's disease or not, there is a plant health effect that causes a stay green effect, right? So in this case, we usually pair insecticide and fungicide together. If you're paying for the application cost, put both products together. And you can just see you're protecting, as we heard earlier this morning, that I very much agree with, solar panels, not leaves, solar panels, right? If you got solar panels, you got a hailstorm, take out a bunch of spots on the panel, that's not a good investment. If you got something feeding on your beans, now they're putting holes in your solar panels. So you're losing yield there. So big proponent for what potential foliar protection can do. And then this is just going later in the season, that stay green effect. And like I said, it's a challenge because we know on the yield side there's almost always a benefit given disease pressure, and in the presence of disease, much higher. But it's a balance that we have to strike. And what's really interesting when we look about this, where is that yield coming from, right? Because foliar protection's typically around here, one pass, probably R3, right? I know some progressive systems are looking at multiple. One pass R3, where is that time-wise? Second half of the season. So now this is where that whole thing comes to. Yield is season long. So at the time the fungicide goes out, you've already set the seed number potential with pods and nodes. And now you have to influence on seed weight. So the average soybean seed weight is about 150 milligrams. And if you can increase the seed weight 2 milligrams, that's 1 bushel. Again, seems pretty simple, right? That's less than 1%. Or 1.5%, sorry. See, I told you I wasn't good at math. But when we look at those same 11 trials and the value of foliar protection, we see about a 3 bushel advantage in these years. It's now a result of seed weight. Here it's almost a little under 1-to-1 ratio. Foliar protection, second half of the season, seed weight. Soybean yield is season-long management. So then the question, though, I can tell you these trials were all pretty well planted after May 10th, when most growers had traditionally been planting soybean. So what's the foliar protection story on those April beans? Maybe we need to change the timing, go out a little earlier, things like that. Well, we predicted that the later soybean might need the foliar protection because they already have a shorter season. And if you can give them stay green in a little longer season, they're going to see the best benefit. Also, they're probably going to be at the worst time of disease pressure and making flowering and pod decisions, whereas the April beans, they might be about tapped out by the time the disease pressure comes in. And shockingly, for the 2022 data, it was always a benefit to the foliar protection, R3, fungicide, insecticide. If you look across this on average, it was worth 3.25 bushels in 2022, really close to that 3.3 that I just showed. And in a higher disease pressure year, right, drought year, no disease, I expect that probably would double, sometimes in really bad situations, triple. So what did we see this following year when we do the exact same thing, the same trial approach? And here it is, and you break it out 2023. And if you look at these differences across planting dates, on average this year it was 4.25 in the absence of disease. So foliar protection for us in our studies is protecting the yield potential and making sure you fill those seed weights. Early planting, right maturity group, that's pods and nodes. Now you need to protect the pods and nodes. Don't give up on them. And in a dry year especially, I think a lot of people may have looked out in June and said, crop's going to do what it's going to do. I'm done. I don't want to put more money into it. And this might show probably still could have gotten some advantage to it. And I'd have to talk the economics on it. We're probably close to break even on this with beans and prices change from year to year. But foliar protection for us in general seems to be a pretty consistent win, regardless of planting date. What about fertility? Right, so here we've now kind of attributed fertility to 4 bushels. And there's some interesting things going on. But when I want to remind you about fertility in soybean, what's the number 1 nutrient we typically throw out there for soybean? Potassium. Why do we talk about potassium so much for soybean? Well, if you look at the removal rates, I'm an optimistic guy, right? So our current state record is 65 bushels. I'm going for 80. So I'm going to put these up also because I think this is the future. In 5 to 10 years, I think most of us are going to be talking 80 bushel beans in certain areas. And so we want to look at these numbers. Here's the total number required to produce, how much goes out with the grain, and then the harvest index. What that means is percent of the uptake in the grain versus the rest of the plant. And there's some key things on here. Why do we talk about potassium? Because potassium and nitrogen are needed in the greatest quantities for soybean. And we know soybean does this thing, nodulates with the rhizobium. Nodules supply the N from the air. You dump nitrogen fertilizer out, the nodules don't develop. And so we don't typically talk nitrogen on soybean. And so we look to the next biggest need, potassium. One of the things we cannot overlook is nitrogen, phosphorus, sulfur. Those are the ones that have the highest percentage ending up in the grain. What do you sell at the scales? Grain, right? So the potassium builds the biomass, builds the factory. It's still important. But if you don't have the right inputs for whatever it is you're producing, can the factory fully give the full output? So don't overlook the importance of phosphorus and sulfur for soybean yields, because that's what you're selling. And that's where, when we talk about fertility in our research, we've actually really focused on the phosphorus sulfur side, less so on the potassium, because we think they're being overlooked. Fertility on soybean, how many of you have looked at it or trialed it or on strips on the farm here and there, right? It's difficult. It's hard to get a consistent response. So we have different sources we can use. We have different timings we can use. I understand in the fall, what do you have? More time. I mean, once the crop's off, tillage, fertilizer, but there's a lot more wiggle room. What are we having less time to do in the spring these days? Plant. And we've got faster equipment, better technology. We can move across a lot more acres more quickly. But the reality of it is our planting windows seem to be getting tighter and tighter, right? Our research program is growing and growing, and I plant my plots at 2 miles an hour. And sometimes it's just, I hope I have enough days to get them all in on time, right? So we did look at timing of fall versus spring, phosphorus as microessentials S10 on soybean the last 4 years. And so what I've got here are the last 4 years, the average yield, and then the fall versus spring application. This is going to be, we use a couple different rates, but it averages out to about 60 pounds P2O5. And what I'm going to show you are the first 3 years. So here are the yields, and I'm going to make it easy for you. Where they're in the green, they're higher than the control. Now, economically, right, biologists, I don't think, if this one may pay here, the 4-bushel response here, but you'll notice they're minor increases. So the economics probably aren't there in this situation. We're going to talk about why fertilizer doesn't give us the response on soybean that we usually see on corn here in a second. And then the other thing to note, though, is we always beat with fall application over spring application. Now, we know there's a little nitrogen out there with that fall-applied phosphorus source. So are we recommending fall-applied phosphorus and the nitrogen when we talk about nitrate loads? That's another discussion that we can have. But one of the things that you have to remember, what is so different about planting soybean rather than planting corn? It's what you're planting into, right? So soybean is going into corn stover, no matter whether it's no-till, strip-till, conventional till, a lot of residue. And one of the things that I get excited about is residue. It's going to be something we're going to have to really be thinking about. But if you put a little phosphorus, nitrogen, sulfur out in the fall on top of fresh corn stalks, perhaps actually we're stimulating a little mineralization, and that's going to benefit us at planting in the spring for those soybean to get a more uniform emergence. Marcos Lohman has been talking about this. This is where he originally started those discussions. Give credit to him. He's the student that thought about this, and it's something we're going to go try and measure and look at fall versus spring and the residue decomposition. But it's my theory today about why fall fertility on soybean makes sense, because are you treating the beans a little bit? You're probably also treating the residues of the corn stalks, helping them break down in the fall before the winter and the hard freeze hits. All right, so it's the second time today that I've hidden something from you, and some of you are probably wondering, why is 2023 not showing up? Well, like anything in good research, you get 3 good years of data, and we want a 4th because it's one site before we publish. And what happens? You get the different result, right? So no matter what it was, fall versus spring, you're better off to plant the beans and walk away. We planted these beans in April. Actually, these went in, I think, April 13th or 14th in 2023. Do early beans maybe need fertility? I don't know. Or we did see a growth advantage right off the bat. You know what the problem with a bigger plant? Bigger plants use more water. And there's a really good chance when that water turned off in June, the bigger plants crashed a little harder because they were using more water, using it faster, and they ran out of water faster, and then that actually takes you downhill. So did we miss something there? Strong start, but couldn't finish because of that. Still working through that, but in general, if you average it, if you're doing fertility via phosphorus or sulfur on beans, there might be an advantage to that fall application over the spring application. So now we're going to tie fertility and foliar protection together using that planting date study. And if you look at the different yields for 2022, right, blue bars doing nothing, red bars fertility alone. You notice, we also decreased yield in 2022 on the April beans. Fungicide here, foliar protection is in green, and then the yellow is if you put them together. One clear trend tends to stick out. They're additive. So doing both of them tends to be better than either alone. And if you had to pick one, foliar protection, like I said, is our more consistent response. And then if you really break it out, here's the advantage, right? So 4 bushels to the system, 3, 6, or 4. Like I said, unfortunately in these scenarios, I don't think we paid for it. Be straight up about that. Biology shows what's going on the yield. We have to do the math to make sure it brings an ROI because 75 bushels without doing anything is still not a bad day, right? Sometimes in research, we're getting really high control yields just because we planted early, and sometimes we get minor results on what we're looking at, but just something to consider. So repetition in education is everything. So I've been showing you 2022 in this study and 2023. Here's 2023. So a reminder what those bars kind of looked like in 2022, and here's 2023. Mostly the same thing, but for the most part, you can see oftentimes the orange bars and the blue bars are pretty well the same. So fungicide in 2023 with insecticide was driving our best responses, was not fertility. Again, I think in a dry year, that fertility, if it builds biomass, then you can't get it out on the back end if you really run out of water, or when you have slow growing soybean, maybe they don't need the fertilizer as much. I mean, this year's corn crop was real short. Our soybeans, they stalled forever. Same field 3 weeks in a row, I'm like, they haven't changed. If their beans aren't growing, they're probably not using the fertilizer. If we had a more wetter year, I expect that response to fertilizer would be better. I can't predict the weather these days, so we just have to, do our best. Maybe we should have, these are all spring applied, I should mention that. Maybe we should have applied it all out in the fall. But then if you look, this is interesting though, the key thing that we saw this year, later planted soybean needed the management the most. Some people might think if you're planting into cool, cold, wet soils, you probably need more management because the nutrients aren't cycling, because the microbes are still sleeping. But we tend to see the opposite. The later planted soybean needs the management. Why is that? They're behind. April soybean, for those that have done it, it's scary because they're just not there, then they're above the ground, they're moving so slow, they don't look so great, they grow very slow, but they have a longer season to do it. You plant beans in June, they're out of the ground in 5 days off to the races. I mean, they are screaming, and they're behind. And so management probably helps them catch up. So we tend to see later planted soybean might be more responsive to management. So when you start doing the economics, if you get out early enough, you could just plant them and walk away and probably have a pretty good yield, and maybe you don't need some of the inputs. Not what we thought would happen, but it seems that early planted soybeans are pretty hardy workhorses. Just let them do their thing. And then if you break it out, like I said, we had 16 varieties. We have 15 of them shown here. And the key thing in 2023, largely, this is the positive response to management. Fungicide every time. Fertility was kind of a hit or miss. I mean, if you had the right variety, 4.2 bushels. Some varieties don't like fertility. So fungicide was the key protection here. I will say in general, in a dry year, if this was the driving fertility less responsive, we do tend to see you put the two together, it is synergistic in more normal years. So why is this? What's going on? One of the things that is important, and we hear a lot more about soil testing, looking at the soybean seasonal phosphorus uptake rate. Again, I gotta give credit to Marcos Lohman, who really put this concept together and created these next few slides. So here is soybean developing through the season. Here's the daily phosphorus uptake of that soybean plant. And what you'll notice is there's two different phases, right? Initial growth, not much going on. You don't need much phosphorus per day, less than 0.1 pounds per acre per day of P2O5. But at peak uptake, which happens to be extended a couple weeks there, you need up to 0.8 pounds of P2O5 per acre per day. And when we think about soil supply, on soil A, on a daily basis, that soil might be able to produce anywhere from 0.3 to 0.6 pounds of available P2O5 per day. Remember, soil solution replenishes itself, but it's a daily amount. And to maximize yields, you have to hit the peak uptake rate. This is an example for 60 bushel soybean. Guess what? 80 bushel soybean, they need about 1 pound per acre per day. And so now you have an even higher limit to catch. This is what we think is limiting yield, and this is where fertilizer has its place. This is the same story for corn. It's even more drastic because corn has a really fast uptake. I think it's almost 2 to 2.5 pounds of P2O5 per acre per day when you look at its peak. And so this is where fertilizer supply comes into play, supplementing the soil. But if you're on soil B, Sometimes some soils can release almost a pound of P2O5 per acre per day, and that may be why we're not seeing response to fertility. So this is why when you just take a soil test and that soil test might say, yep, this is going to work or not, you have enough to go with, perhaps it's not that it's all there, but it's the daily availability. And that's what we're really going to push forward in a lot of our research moving forward, is understanding the daily needs and ensuring we can get that through things like the 4 R's, the right rates and placements. Lastly, we're going to touch briefly on seed treatment. We give it 2 here. This is more thinking kind of the traditional Brady rhizobium, right? So soybean does this. It fixes nitrogen through the rhizobium and the nodules. And you got N2 coming out of the air and going to a usable form by plants. Active exchange. We've done Brady rhizobium inoculants in our studies and see plus or minus 2 bushels. We've been doing corn soybean long enough in our Illinois plots. There's enough in native inoculum to do this on its own. And when we think about why they do this, they need a lot of nitrogen, about 4 to 5 pounds of nitrogen per acre per day for soybean. And they get about half or 50% of that from the nodules, the other half via the soil supply. Soybean needs 4 to 5 pounds of N per bushel. I'm convinced that soybean yields might be nitrogen limited, but we can't pour it on via fertilizer. So maybe we need to maintain soil supply and get this up to 60%, 70%. Can we increase the fixation efficiency? And we've been doing that with a little thing called molybdenum. Now molybdenum is important for the enzyme that takes the N out of the air and puts it in the usable form. You need molybdenum for that enzyme to work. So why not put it right on the seed at planting, and the native Brady rhizobium now have the tools they need to do their job even better, right? Don't send somebody to do a job and don't give them any tools. Then they can't get it done. But you give them the tools, the natives, they colonize, they nodulate, and they can do it. Here's the yields. We have 2 different years, a 2-year average that we've been working with, 2 different rates of seed treatment. I'll just color code it to the visual response. On average, we're getting about a 2 bushel response. Now I can tell you as an academic, I will never prove statistically 2 bushels on top of 80 without 20 replications or 3 sites. It's just the statistics won't get that. That's really hard to detect. But if I tell a grower in 4 scenarios, I'm getting about a 2 bushel response to a seed treatment, this does pay. And it's pretty easy to do, treat it, put it out across the acres. So just something we just started with. The idea though is we think we're enhancing the fixation potential because we're just giving the soils, microbe soils, the tools they need to do so. Other things of interest are these bacillus, right? So Brady rhizobium may not be doing it, but can we look at bacillus? We're doing seed treatment and furrow inoculation. Some success on this. We are excited about the potential. Not quite ready for some commercialization, I think, but we're going to get that answer to you. So the last thing I'm going to touch on, and we're going to kind of go through this quickly because I'm right up about on my time, but we do have Darby Danzel in the room, and she's doing cover crop management. So we've gone through the 6 secrets, but what's the next steps? Cover crop or double crop, right? So we did standard stalk rollers or sizing on the corn. What would you rather drill your cereal rye into? This or this? The idea here is this can help us get a better cover crop stand if we're drilling after harvest, perhaps helping the cover crop get off to a good start. But then you have to manage that biomass. So we have cereal rye in this example. We're adding ATS, ammonium thiosulfate, 7 gallons to the acre at termination. And then we're playing around with some of the biologicals, right? So this is a living microbe to degrade residues, and this is just simple sugar and humic acid, feed the natives approach. Why inoculate when we can just stimulate those already there? Just so you know, you put ATS in the tank, 3 days later I can go out and make sure Darby sprayed the right plots because I can see to the row. Good job, Darby, you got them all right. And it knocks it flat real fast, 3 days later. For reference, there's those bacillus that I was talking about, new products coming out of market, that's the residues, applying a living microbe. Or we're using Neovita 43, it's corn syrup, right? And hydrohume, humic acids. Quick sugar, quick energy, probably burns up real fast. And then like a complex carbohydrate, feed the microbes for the long run, get them off to rolling, stimulate the natives. What you're gonna see are untreated control, 89 bushels, right? Like I said, we're getting some phenomenal genetics these days. We lost 10 bushels to that cover crop. 2 things to state. I planted 75 pounds to the acre because we drilled it late and we wanted a good stand and it stood. We had a lot of biomass, 2 tons of biomass, a little over recommended rates, and we had a dry 22, put 2 tons of biomass, sucked up probably a lot of the soil moisture, and dry 2023. So I would say this is probably worst case we're going to experience, first look at this system. But the cool thing was when we added these treatments, we started to get the penalty back. So we might be able to add things to the tank at termination, don't have to pay for the extra application, and at least mitigate, and I think in a more normal year, we may have surpassed 89 on many of these. And the key thing is it looks like the ATS is driving the response the most in this case, and then you do the economics. When you look at the chopped yields, right, we did see that sizing actually reduced the cereal rye stand. We'll have some insights to that at the poster session. And they weren't as consistent, but ATS seems to be the driving factor. So if you're going to try something at cover crop termination, maybe ATS. So we have some key takeaways that are on the poster. All treatments cereal rye numerically increase the yield compared to the unmanaged rye. And then there are some effects that can be an additive on a standard sizing. If you're chopping, really we found ATS was the best move to go through. So to wrap up here and conclude, here are the 6 secrets of soybean success, and if you add it up, what's that total? 80 bushels, right? That's what I think we're excited about. So always take your field scout to the field, though, to double check, right? So here's my field scout, Paisley, and in 2012, she's pretty happy with 60 bushels. But then we went to the next plot where we're doing some of those 6 wonders. We got 80 bushels, and that's something to be really excited about, right? So the secrets to high yields, make sure the planter's ready. That's the first thing. But then you have the decision to not use it. Don't forget that part. Field conditions are probably going to be important, but like I said, there's pretty good potential with less of a risk on that, especially if you think compared to corn. Longer or maturity group tends to be the way to go. We're filling seed with foliar protection, and fertility may be best in the fall, but we tend to see if you're doing fertility, foliar protection has an advantage. So last things is, 60 bushel beans compared to 80, 33% increase in our nutrient requirements. Have we been accounting for that in our soybean systems? Probably not. Maybe on the potash side. But think about the amount of phosphorus, sulfur, nitrogen, micros we now need to go from 60 to 80. It's going to change our minds about what it's going to take to get there. So special thanks. I apologize. I'm 2 or 3 minutes over, I think. But that's what I've got for you.
All right, let's thank Dr. Sible. All right, we are a little over, but if you're willing to stick around, we could take 1 or 2 questions.
And I won't be leaving until I'll be through the poster sessions too.
Okay, the question was, what kind of rate for ATS with cereal rye?
We're putting 7 gallon to the acre. That gets us 20 pounds of sulfur, because Castile's work says sulfur on soybean about 20 pounds. So that's why we chose that rate.
Did you look at variety yield, but then the difference between spacing, like 20 to 30 the same variety?
Yep, so the question is, in the 20s versus 30s in the planting date, do we look at every variety? Yes. If you go to our website, the entire yield report for every variety, every management, any way you can slice and dice it, for both 22 and 23 are at the top. There's still links posted at the top of that link. Yep.
Okay, 1 more question. Todd.
Notorious too cheap, get it in April, no till. If it's dry, I forget which way it is. Do I use the foliar fungicide or not use the foliar fungicide and wet? What's the difference?
So I think the question was no-till? So one thing I will clarify, these are all conventional, so no-till does change the game, especially on field conditions. That's something to consider. And then the follow-up was, if you're no-till and early, should you or should you not use the foliar protection? When dry?
Both ways.
Yep. So in general, our data has found in the conventional systems, dry or wet years, foliar protection has a response. It's better in wetter years. But from the economics and the IPM perspective, if there's really no disease pressure out there, that's decisions that have to be made as well. But in general, we're seeing foliar protection is consistent in almost every scenario we've looked at.
Great. Let's thank Connor again.
Sorry.
All right, so we'd like to thank Dr. Sible again for joining us. There are CEU credits in the back of the room if you're a CCA. If you don't catch it in this room, it'll be in the main hallway. And the next session will start at 3 p.m. Thank you. All right, everyone. We are going to get started with our third and final session of today. If you want to find your seat. All right. Welcome, everyone, to the third session in today's research breakout room. My name is Jennifer Jones, and I am the research agronomist with the Illinois Soybean Association. Before we get started, I'd like to take a minute just to thank this session's sponsor, Benson Hill. Let's give them a round of applause for their support of Soybean Summit. Thank you. Thank you, Benson Hill. All right, originally this session was going to be led by Dr. Aaron Hager. However, he is unable to attend today due to sickness, so we have Corey Lacey instead, our wonderful colleague at the Illinois Soybean Association. He is a regulatory public policy manager, and he has graciously offered to step in and discuss the Endangered Species Act and proposed changes to herbicide labels. So Dr. Lacey focuses his time advocating for Illinois soybean farmers on conservation and environmental policy issues. He holds degrees in environmental soil and water science, agriculture science, and soil fertility and conservation. Prior to working at ISA, he managed an agricultural testing laboratory based in central Illinois. Additionally, he has over a decade of agronomic experience working with Illinois growers. So before Dr. Lacey comes up, just as a reminder, if you have questions at the end during the Q&A period, please use the microphones, or we'll have Corey repeat your questions so that those online can hear as well. So thank you, and please join me in welcoming Dr. Lacey.
All right, so thank you everybody for coming and letting me talk to you today. I know you were expecting Dr. Hager, and you're going to be disappointed by me, I'm sure, because he's a much more intelligent man than me, but hopefully I can get at some stuff. You know, this is a research session, but we're going to talk a lot about policy today, and I think that that's an exciting thing. That's something we should be talking about more about. So, title, Navigating a New Era, Understanding the Endangered Species Act and its Impacts on Pesticide Regulation. So just to get a couple things out of the way, first off, as it's been pointed out, I'm not Dr. Aaron Hager. The reason that that's up there is I've given this presentation a couple times now. These slides are actually some that he put together, but I like to give him credit for putting together the slides, but just be specific in what I talk about today is either my position or Illinois Soybean's position. The other thing I want to highlight is we're going to talk about policy issues from a very almost theoretical space, from a proposed, everything we're talking about is mostly proposed. And so why I highlight that is it's all subject to change. And we all know things are subject to change anyway, but it's important to start with that position. These are things the Environmental Protection Agency has told us they're thinking about doing. None of it's been finalized. The last thing I want to just kind of highlight before we move is that we're dealing with a complicated issue. It's a space where environmental policy, agriculture policy, political issues and political priorities, and science all intermingle. And so that makes it very complex. And so I will tell you my perspective, my interpretation, but just everyone's on the same page. I'm not a perfect person. I could have something wrong, and I'm happy to discuss that. So when I think about the herbicide strategy, and I'll just start off. Who in the room has heard about the herbicide strategy? Okay, one or two people. You're going to start hearing about it even more. Who in the room has heard about the Endangered Species Act? Okay, and everyone knows who the Environmental Protection Agency is, right? Okay. When I first started looking at this, and this has been over a year now of kind of thinking about it, the thing I had to keep reminding myself is that there are some really, I believe, well-intentioned people in DC who have said there's an issue we have to address, and they feel like they've come up with a simple plan. And I thought about this comic that actually my son shared with me, but our simple plan, and then you look at that, it's not simple. And when we deal with the Endangered Species Act labeling and pesticide regulation space, that's exactly what we're facing. We have people who have created policy that feel like they've come up with a very simple plan that's not simple. The herbicide strategy is an example. It's a 900-page document that's going to affect all herbicide use across the country for every farmer. So there's no way that could be simple, but that's the perspective that we get from DC. And so I think that that's just an important thought pattern. So why do I say it's not simple? First, and I'm going to just kind of interweave this thought throughout the talk, but there's more added layers of complexity. So the kind of thesis of the talk is how agricultural pesticides are used in Illinois will become more complex. So what does that complexity look like? We're going to see increased complexity on our labels, okay? How many of you have heard of Bulletin's Live 2? Anybody? Okay, so if you want to know what your pesticide label looks like right now, what do? What do you look at? The bottle, right? Okay. Moving forward, those labels are going to change. We're going to see dynamic elements of those labels. So instead of what we usually consider as a very static process, we're going to have an online portion of the label where we have to get online or on our cell phones and check and see, has the label changed? We're going to see an example later in this talk of where that label has changed from year to year. So I want you to think about the relevance of that. If where I can and can't use pesticides and how I can use them changes year to year, that really adds complexity. And what that also adds is this thought process of we have to increase the amount of record keeping. And I don't have a solution for that, but I will say that that's some space that farmers need to start thinking about. How are we record keeping better? How are we proving that we did things correctly? How are we proving that we're following the rules? The other area of complication is, or complexity, I guess, is regulation. So where that's going to increase is, there's a couple areas where that will increase, but the one I like to highlight is your location of your field. So what we're going to see moving forward is that where we can and can't do things with pesticides is going to depend on whether or not that field is in the range or the county where an endangered species is present, okay? So, or where it's thought to be present. And so what that means for us is that a field in one part of a county, you may have different rules than a field in another county, part of the county, even if it's just a mile down the road, okay? So again, there's this added complexity of thought. And then possibly my biggest, I hesitate to say biggest because as we get into this, there will be a lot of things that are my biggest concern. But one of the biggest concerns is the complexity of misuse investigations. So I think we all are very aware that there are pesticide misuse investigations that happen now. A lot of times they're around drift. Did I spray and hit a neighbor's tree? Something like that. When we enter this Endangered Species Act part of this equation, all of a sudden we're opening up a whole new space for both civil and criminal lawsuits to occur, but also for a whole new set of rules that we have to follow to make sure that we're in compliance. And the level and intensity of that is going to go way up over the next few years. And my concern there is, A, we don't know how that's going to be enforced. We assume that IDOA will be the enforcing body because that would make the most sense. But I would question, is IDOA equipped to monitor pesticide use on every state or every field in the state on that level? And we also see, and we'll talk about this more, there's a lot of engagement from environmental groups on this, on the other side. And there's a lot of concern about, are we going to see environmental groups intentionally monitoring farmers so that they can capture an accidental misuse and bring a civil case about that to try to pressure people to continue this concept. So we don't know where the protections are. We also don't know where the responsibility lies. Right now, I don't know, it's unclear if the commercial applicator is responsible, if the farmer would be responsible, if the landowner is responsible. There's just a lot of questions there. So I'm just giving you these things to say there's levels of complexity that are going to increase. We're going to dive into some of this, but this is why I'm concerned. This is why I want you to be listening to this. So if we step back, I think we have to ask ourselves, what's driving these changes? And so, any guesses what's driving the changes? I maybe hinted at it. Ron? Yeah. Environmental protection, Ron said lawsuits, and we're going to get to that because that's absolutely true. The key aspect of what's driving this is the EPA and the Endangered Species Act. And I think that makes us have to ask ourselves, what's the role of the US EPA in pesticide regulation, and how does Endangered Species Act play into that? So I'm going to break it down. When it comes to pesticide policy in the US, there's two bills that you have to know. There's FIFRA. Who knows what FIFRA is? Anybody? Federal Insecticide, Fungicide, and Rodenticide Act. Okay, what's important to know about FIFRA is it was written with the express intent of regulating pesticides. It gave the EPA authority to regulate pesticides in the US. What is good about FIFRA, and I think a lot of us, BASF is in the room, they maybe differ, but one thing we can agree on is that FIFRA, in a lot of ways, has worked for farmers. It's worked for agriculture for 50 years, since 1972. It hasn't been perfect, but it's been a solution we can work with. And the reason is because that's a risk-benefit statute. And I'll just read the language on here. Any unreasonable risk to man or the environment, taking into account the economic, social, and environmental costs and benefits of the use of a pesticide. So, if you leave here knowing anything about FIFRA, I want you to understand that it's a risk-benefit statute that allows for that assessment of what's the value of the pesticide, not just the concern about the damage. Now, the other piece of legislation that's now entering this space is the Endangered Species Act. And I want you to look at this slide. So 1972 was FIFRA. When was ESA established, according to the slide? Was it a long time later? 1973. So it's been in place for 50 years, okay? That's key. We're going to be talking about this, but this is not new legislation. That's an important thing to bring up. What the Endangered Species Act does is it's very distinct from FIFRA because it's a, how do I want to say it? It's a thou shall not statute. It says that any federal agency shall not endanger or negatively impact a protected species or its environment, or the actual language is habitat. And that's important. It's not just about we can't go and accidentally kill a protected species, we also can't damage the environment where it might live. And the difference there, right, is there's not as much wiggle room in that. There's not flexibility for agriculture to say, well, what about the economic benefits? What about the feeding the world benefits? It's just you can't do it. Another thing that I think is important, because in agriculture we think of ESA as very ag-focused, but it actually applies to all federal agencies. Department of Defense, DOE, everybody has to comply with Endangered Species Act. And that's important because it was not written with the intent of regulating pesticides. It was written with the intent of protecting endangered species. And those are two different goals. And it's important to understand that distinction. So just diving a little bit deeper here, the Endangered Species Act says that any federal agency cannot jeopardize the continued existence of any listed species or destroy or adversely modify any critical habitat of those species. So why do we care about that when it comes to pesticides? The reason we care about that is because the EPA under FIFRA has the responsibility to register pesticides for use in the US. Every time they register a pesticide for use in the US, that's an official agency action that has to be in compliance with Endangered Species Act. Okay? So why am I concerned? Is my corn and soybean field a habitat for an endangered species? Do you guys feel like there's endangered species in your corn and soybeans fields? It's not a natural habitat for sure. But whenever we apply a pesticide, and we know this, whether it's a few feet or a mile, there is a footprint, an ecological footprint around that pesticide application where it leaves our fields. We've talked about this with years for nutrient loss reduction strategy issues, but that's the concern here, that footprint, that pesticide leaving the field that has been allowed by the agency action could hurt an endangered species. And that's where that's the violation of the Endangered Species Act that they're concerned about. So it's a little bit of a nuance, but I want to make sure we're tracking through that. So I highlighted that FIFRA 1972, ESA 1973, it's been 50 years. Why are we talking about this now? Ron, you said it earlier. Why are we talking about it now? Lawsuits? Okay. We're going to get there. I would argue that why we're talking about this now broadly is because the regulatory landscape in the U.S. has changed. And one real highlight of that is, this is Jake Lee, who is the Assistant Deputy Director of the US EPA Pesticide Program. And at the Weed Science Society of America in 2023, he came on board and said that, and there's a lot there, you can read this whole thing, but what I want to highlight here is the agency had registered and re-registered pesticides without going through the ESA process for decades. So this is the agency admitting that they have not met their obligations. Okay? And that concedes, that is the pinnacle, or the key signal to me that there's been a major regulatory change in the landscape. What does that mean for us? First, it means that the EPA has admitted that they're not doing it. Why they've admitted that is because of continued litigation. What that means for new active ingredients is that we're going to see ESA policy labels on all new active ingredients. That's a order that's come down through the EPA right now. So anything new is going to have ESA labels. It means that we're going to see litigation and court action. I'm not a lawyer. I'm not going to pretend like I am. But we have seen clear evidence that the courts can stop pesticide use. They have the authority under our government to say, EPA didn't do their job, so we're going to pull that registration, and we're not going to be allowed to use it. It means that when pesticides come up for re-registration under EPA, which is every 7 to 10 years, an ESA label is going to be applied to them. And also, one thing I would really like to, I guess, characterize about this situation, this landscape, is that we want to think of it as a science-based approach. I think as agronomists, as farmers, we want to believe that things are science-based, and traditionally they have been. But what we're seeing now is that there's policy impacts, but there's also political things at play here. And I'm not going to surprise you with that statement. I think we all in the room understand that politics plays a role in our lives. But I am going to illustrate something that I think helps us understand that a little bit better. So this is an executive order issued in January of 2021. And I'm just going to highlight some language in that. So it's just blown up. But basically it said, it was Biden saying we need to work on our federal policy around protecting the environment. But some of the language in there, I'm just going to read this to you. The heads of all agencies shall immediately review the existing regulations, guidance, policy, and actions issued and adopted between January 20th, 2017 and January 20th of 2021. They didn't say over the last decade. They didn't say in recent years. They're all currently active. They said those 2 dates. Who was president during that time period? Trump. And who is president now? Not Trump. That may change in a few months, I don't know, but right now he's not. So I'm not saying that this is good or bad or that politics shouldn't play a role in our conversations. I work for government relations. I would argue that politics should play a role in good public policy. But I think that this is a clear example of where politics have played a role in a way that impacts us on the farm level. And I just think it's important that we understand that. I'll let you guys think about whatever you want to think about there. So before we move any farther, I kind of want to, let's deep dive into the Endangered Species Act. So I want to talk about the structure of the Endangered Species Act. And I'll just caveat this with, I'm not a lawyer, I'm not a legalese person, but when I dig into this, when I talk to other people, I think the ESA was structured in a way that was intentionally designed to be burdensome and to be ripe for litigation. And I think we see evidence of that in our, and just in the public naturally. We see lots of examples of ESA lawsuits. I would argue that it was probably intentional. There's language in there that I've at least been told what it basically does is it makes it very easy for the individual citizen to bring a lawsuit against the federal government. And again, I'm not saying that's good or bad, but that's an element that's built into the Endangered Species Act. Why we care about that is because what's happened to that, I think, probably well-intentioned initial language is it's been co-opted by anti-pesticide, anti-GMO groups as a tool to go after us as an industry. And I think that's important to remember. I think there are a lot of good-natured people, or sorry, not good-natured, well-intended people who really, really want to make sure that we are protecting endangered species. But I think there are other people who are more driven by, we want to get rid of pesticides, we want to change the way we're doing agriculture in the country, and they're using ESA as a tool to get there. And the reason I highlight that is because I think it's important for us to understand it's not necessary, this whole discussion is not about the facts, it's about the remedy, it's about the underlying intents of the motivating of the groups, okay? And the reason I say that is because I know of no example where an endangered species has gone extinct due to pesticide use in the US. There's really not a good example of that. So it's not about the facts. These things haven't happened. It's about, okay, this is something we're scared of, we're going to talk about it, and then we're going to use that as a way to motivate public policy so that we limit pesticide use. And I would argue some groups want to eliminate pesticide use. You know, that's a whole different conversation. And I think some illustrations of that, you know, I won't read that whole paragraph down there, but the EPA is under a lot of lawsuits on this issue, dozens at any given time. So this is important to understand. The motivator here is the EPA is being sued by the other side. Not by us, but by the other side. So what does the Endangered Species Act do? You know, we see a lot of numbers. When actually Dr. Hager made this slide in 2022, there were 1,600 species on the listed. 895 had critical habitats that were protected. What I want to highlight here, the biggest group is plants. When we think about pesticides in plants, what are we thinking about? What pesticide are we thinking about? Roundup, herbicides in general, right? Here's the first thing that came to my mind. Glyphosate. Glyphosate is up for re-registration in a few years. It is, the reason that it works so well is because it's good at killing plants. Am I wrong? Right? That's why it does its job. It's also likely going to be good at killing the protected species that we're talking about. And so what that means is, if we're following the train of thought here, we're looking at a lot of regulation on things like glyphosate. I think that's something we need to think about. Because how many people in the room use glyphosate on their operations? Okay. I saw one person not raise their hand. I won't call them out about it. But I think, just to be fair, right? And also, I think we should recognize glyphosate is really commonly used in the urban sector too, right? You go down to Lowe's and buy glyphosate for your house. None of the regulation we're talking about impacts urban use at all. We're only talking about agriculture. So what are the challenges? First, I mentioned it multiple times, there are court rulings. We can go into the details of the court ruling, but basically, one environmental group sued the EPA, said you weren't meeting your ESA obligations. The EPA fought that for years, and then they've lost. The final agreement, or the final decision around that court case happened in 2023. The preliminary agreement happened in, I think, 2021. That's why we've been talking about this for a while. Part of that is the EPA has agreed that we're going to create a plan to be in compliance with ESA obligations over a set timeline, an accelerated timeline. So this court order is in place. It has to happen. And I think that's really important. This is not a conversation about, well, if we elect the right person, can we change this? It's in place. It's a court order. It's going to happen. I think the other thing we have to acknowledge is that the EPA is not necessarily the bad guy. They are just the tool that's being used in this situation. And we need to help them come into a compliance. And the reason I say that, and that may sound wrong, why do I want to help them come into a compliance? The reason I say that is because if they don't come into compliance, that leaves the pathway for the courts to pull registrations. So I would argue that the only other option, if the EPA doesn't get into compliance, is the courts will start pulling registrations and we'll start losing pesticide tools. And that's a real fear. We should be scared of that. One question I a lot of times get when I talk through this is, why hasn't the EPA been working on this for 50 years? And I would say they have. The problem is it's a complicated issue. It requires, if you're going to do it right, it requires a lot of science. So what the EPA tells us is that one product can take anywhere from 3 to 12 years to study and determine what the label should look like. Their estimates to come in compliance and review all their products is 360 years. So not even within a generation could they come in compliance using their current process. So the challenge is, they've been court ordered, they have to come into compliance. If they don't, there's a bigger threat if they don't come into compliance. The process that's science-based that they have established doesn't work. And that's what's making them, we have to rethink how we do things. So we're going to talk about a little bit about what that looks like. So first off, are any of you guys aware of how ESA has impacted your label, your pesticide use in the state to a point? Have you thought about it at all? Do you think that ESA is impacting our labels currently? My question's kind of leading, right? I got a little bit of a chuckle here, okay? Yes, it is, okay? This is dicamba, all right? The pink areas are generally what I'm referring to as endangered species counties. And there are counties where we've determined that endangered species are there, and so there are different rules about dicamba in those counties. So if you're inside or outside of that county, the rules change. We'll talk about this in a minute, a little bit more, but this is also an example of Bulletin's Live 2. This is the online version of our pesticide label that we'll have to start watching in the future. Another example, and I don't know the specifics of this herbicide or this pesticide, but what I'm trying to illustrate here is there was a pesticide that the EPA even put out an announcement while Trump was in office saying, hey, no health risk, looks like it's a positive, it looks like a good tool for farmers. And then in 2022, it changed because of this Endangered Species Act stuff and forced the registrant to say, well, we just can't continue forward with this product because there's too much uncertainty in the market about whether or not we'll be able to use it, where we'll be able to use it. Burleson, you might be able to talk a little bit more about that. No? Okay. I'm not picking on this product. I'm definitely not picking on BASF. I'm illustrating that the result of this policy has been we have less tools that we could use in the field already. And they haven't even fully gotten implemented. This is just the threat of what they're going to do has stopped policy. And BASF is not the only company that's made these decisions. Now, how many of you use Enlist? Everybody, maybe not everybody, but most of us. One of the best examples of what this is going to look like on a pesticide label is our Enlist products now. So this is your current pesticide label for Enlist. Okay, how many of you know that there's mitigation requirements on your Enlist pesticide label? For multiple years. If you applied Enlist the last 2 years, this was on your label. Don't raise your hand. Don't raise your hand. Frank, you, of course you knew. Okay, good thumbs up. What I want to highlight here is this is a great illustration. I think this was EPA's test run on what these might look like. So what this is highlighting is based on your soil, so C and D is kind of a common soil in Champaign County as an example. You either have to earn 4 or 6 credits to be able to apply Enlist on each field. So then you have to go over to this label and determine how many credits do you have. All right? So when I usually walk through this, the first thing I say is, okay, I'm on 6 credits. I'll just do 1 application of Enlist. Is that reasonable? How many people do more than 1 application of Enlist? Some people do, some people don't. No one's interacting, but I'm going to assume some of us do. But okay, fine. We can do 1 application of Enlist. That gets us 4 points. Now we need 2 more points. Okay, we put in a vegetative filter. Well, it seems kind of arbitrary, right? Because if you put in a 30-foot filter, if you're on AB, you get 2 points. If you're on a CD soil, you get 0 points, so it didn't do you any good. If you put in a 100-foot strip, you get 1 point. Sorry, my clicker's not working, right? So now I'm at 5 points. So now at this point, to get 6 points, I have to choose one of these other practices to make sure I'm in compliance before I apply the product. Okay? I think you have to think about that. And what I also want you to think about is that complexity of our management and a complexity about our record keeping. How do we prove that we did these things? Right? Some of that's already in place, but that's stuff we have to be thinking about. The other thing that I want to highlight is if you read the top of this, the land manager and applicator must effectively implement these measures. Who's the land manager? Is it the farmer? You said you, so I'll pick on you. Yeah, the farmer. Is it the landowner? Is it a land management company? Is it the trust that the land's held under? I don't know. That's one of the biggest questions with this. We don't know who's at fault. We'll dig into this a little bit more, but this is a big question. Who's at fault and who's responsible? My biggest concern is the farmer has to get the product applied, so this is going to fall on him to figure it out. Now, we're going to have allies in the industry that are going to help us, but it's going to fall on us to figure it out. Other, restrictions. So a big part of this is there's this point system and pick list, but then there's this other concept of there's just straight restrictions. You just can't do it no matter how many points you have. Some of those these are all proposed, just so we're clear, but do not irrigate within 48 hours, do not apply within 48 hours of irrigation. I don't know how, irrigation happens in Illinois, it's not a big thing. Out west, that's going to be a bigger issue. What I'm really concerned about is the second bullet point. Do not apply this product when the soil is saturated or at field capacity, or when a storm event likely to produce runoff from a treated area is forecasted. How do you determine that? Can you tell me? How do I know if a rain event's likely to produce runoff? I don't know. When we talk to the EPA, what they've shared to us in writing is what that probably is going to look like is if NOAA, the National Weather Organization, if NOAA says that there's a 50% chance of rain within 48 hours of the pesticide application of an amount that's likely to produce runoff. Okay, so that's helpful, right? 50% within 48 hours, but we still have that's likely to produce runoff. I don't know how to determine that. I don't know how to help you guys determine that. Because that's dependent on slope. Like if I'm on a flat surface, okay, that may never happen. But if I'm on a slope, that's going to be a lot more likely. Is that an inch of rain? Is that half an inch of rain? We don't know the answers to these questions, and that's something we have to understand. Also, I'll point out, this was pointed out to me yesterday, a lot of pesticide labels currently say that you should apply before a little bit of rain because it helps work it in. So where's the balance there? Also, I'll just challenge you as farmers, if you look at if you know you have to get a pesticide product out there, and you look at the forecast and there's a rainfall event in the next 48 hours, and you know that may be your last opportunity to get that product out there, what are you going to do? You're going to go look and see that you can't apply it and just be happy, right? No, that's not what happens. The last thing I want to talk about with this restriction space is the Bulletins Live 2 website. And this is what I kind of call the endangered species part of our future labels. What the Bulletins Live 2 website is it's EPA's website that basically lets them alter or update or extend the label beyond what's on the bottle. And we have a lot of concerns with this. Access. How often do I have to go look at this website? We all have cell phones now, so pop it open on our cell phone. But who's responsible for checking that? Do I have to check that every day? Every time I'm about to go out, do I need to check it? And if it's changed and I can't do what I wanted to do or what I had planned, how does that impact things? These are questions that we don't have answers to. The other thing I want to highlight here at the top. So This is the dicamba map that I showed you earlier. In 2019, there were 27 Illinois counties that had endangered species label on dicamba. The next year, in 2021, there were 18 Illinois counties. So we're moving in the right direction, so that's good. But the complexity there is the list, 14 dropped off and 5 got added. There's no transparency in understanding how that happened. Did all the endangered species from those 14 counties just decide to go to the 5 counties that didn't have it before? Were the maps not good in the first place? Do we not know what we're doing and we're just guessing? I don't know. I don't mean to sound sarcastic. This is stuff that concerns me, though. We're not basing decisions in science. We're painting with broad strokes because the agency has to take action. And we should be scared about that. So now we'll get into what is the EPA actually proposing. There's the interim ecological mitigation strategy. There's the herbicide strategy, and their vulnerable species pilot. These are the 3 documents that we've seen so far from the EPA that are giving us hints at what's to come. And I'm not going to deep dive into these. We can talk about them afterwards. I'm going to give you the 1,000-foot view. The ecological mitigation framework is the core piece of policy legislation around pesticides right now. The draft. It's a draft. And basically it says this is how we're going to move forward to come into compliance with Endangered Species Act. And we're going to do that by releasing pesticide-specific strategies. So a herbicide strategy is the first one. There will also be a fungicide or rodenticide and an insecticide strategy. We're also going to release pilot projects to look at how can we do a better job on specific species. And so we've seen an example of a strategy, and we've seen an example of a pilot project. And I just want to talk about both of those things. So in general, what is the herbicide strategy framework? I won't dive into this. What I want to hit is there's 3 main concerns. These are the 3 environmental pathways for pesticides to leave our fields: runoff, erosion, drift. Okay? Everything about the framework is about controlling runoff, erosion, and drift. What does that look like for runoff and erosion? For runoff and erosion, we're going to see something very similar to what we saw with the enlist label. We're going to have a pick list of items. Each item's going to earn us a certain amount of points. Depending on the pesticide product we want to apply, we have to choose the right pick list items to get those points. We don't know a lot. We've seen some suggested scoring on what these things might look like. The best guess, based on conversations I've had, is that most pesticide products, or most, I'll just say herbicide, most herbicide products are probably going to require 6 to 9 points. That's a guess. That's just my best guess. Any one of these items gets you either 1 to 3 points. Okay, so that right there tells you that most farmers in the state are going to have at least 2 of these practices on their fields, every one of their fields. Likely 3. Some people are going to have more. So what I like to stop and just kind of hover here in which of these pick list items would you put on your field if you don't already have them? And some of us are in a good position. Some of us already are doing some of these practices, or all of them, and we don't need to worry. But a lot of guys aren't. What I will tell you is the USDA and their comments to the EPA on the herbicide strategy said that the implementation of these practices by farmers in Iowa, Illinois, and Indiana would cost $5 billion. That's their estimate of how much the cost of the herbicide strategy would be to farmers. That's real money. I know in the national budget, $5 million is not a lot. $5 billion is not a lot. But to you guys, that's a lot of money, right? We need to be worried. This is serious. This is going to change how we farm. So, drift. Drift, I think we understand how drift works. If we're all being honest, we know that drift happens, right? You don't have to raise your hand and nod, but I know we all know that drift happens. What we don't fully understand, or that's not fair to say. What the EPA is going to do is we're going to affect things. We know what affects drift, right? Droplet size, wind speed, release height. These are going to be new limits. The biggest change that they're proposing around drift, I would argue, is expanded buffers. Either omnidirectional buffer requirements or downwind buffer requirements that are much larger. I've seen estimates, but we're probably looking at least a 100-foot downwind buffer a lot of times, up to a couple hundred feet. They'll be bigger than what we're used to. The other thing I like to highlight is it will likely be on buffers around both public and private land. So you're going to have to put buffers where you're not used to putting buffers. And we have a lot of concerns, right? Because if you have that much of your field that's not receiving the pesticides it needs, what does that do for resistance in the field or outbreak? These are things we have to think about. So I'm going to transition. That was kind of the herbicide strategy. The vulnerable species pilot. This is small. The pilot is a small-scale proposal by the EPA. And you won't think it's small scale when we look at it, but in reference to the herbicide strategy, it's small scale. What I'm scared about the vulnerable species pilot is I think that it is the EPA telling us what they're trying to get to at the end of the day, what they feel like is likely, and this is them testing the water. So they've identified 27 federally protected species that are the most susceptible to pesticides that they really have to protect, and they're going to go in and say, we're not going to just create labels around this product. We're going to restrict use of broad groups of pesticides. So this is the example the EPA gave. For example, EPA may implement a specific restriction to protect Taylor's checker spot butterfly. I don't know what it is, but we all like butterflies. You can Google it. Taylor's checker spot butterfly from all insecticides. Not some insecticides, not these specific insecticides because science has told us that they're a danger. All insecticides used within or near their range. So if you couldn't use insecticides on your ground, would that change your operation? Yes, the answer is yes. Okay. We don't have checker spot butterfly. But what we do have is rusty patch bumblebee. And one thing I'll tell you is the EPA has done a good job of explaining what all these species are. If you Google them, rusty patch bumblebee, EPA, they have a nice website about it. And the rusty patch bumblebee is actually kind of a really cool thing. Apparently, people call it the teddy bear of bees. And as bees go, it is kind of a cute bee. It's a cool thing. I'm being sincere. It's kind of cool. And I say that because I don't want them to go extinct. I don't think anyone in this room wants them to go extinct. But what I want to highlight is they picked this as a species that's susceptible to insecticides, and they've created these zones where they live. The purple area is what's called the avoidance area. So the Fish and Wildlife Service has told the EPA that these are where the rusty patch bumblebee lives. The purple areas. Now, one thing we don't understand is how did they get that map? Is that map accurate? Do you think somebody from Fish and Wildlife Service went to each of those purple dots and checked? They didn't, just in case you're curious. The avoidance ones is the purple area. The purple area, you cannot, and if you just read that language on that paragraph, I won't read it, but basically what it says is there is no pesticide use. I suspect the language is really intended to say no insecticide use because limiting herbicide use because of that doesn't really make sense. But what it says is no use. Now, when I look at that, the yellow and green is the corn and soybean fields, and maybe it's not clear, but because I know most of you are probably not from this far north, but this is Illinois still. There's a little town right here called Chicago. Okay, that was a joke. But anyway, my point is that a lot of these purple areas don't directly overlap corn and soybean fields. Some do, but not all of them. But the real concern is there's this second piece, the minimization area. That's the area where the EPA has said that we want to minimize pesticide use, and we're going to create regulation. We're not going to say you can't use it. We're going to say we got to minimize it. And how they presented minimizing it is no pesticide applications within, or no insecticide applications in this case, within 48 hours. of a rainfall event. You have to, they suggested that you might have to consult with Fish and Wildlife Service 3 months ahead of time. And there's no clarification on what that means. What is consult with Fish and, so first off, who knows where your local Fish and Wildlife Service is to call them? Nobody. I don't know. I do now because I dug into this, but nobody knows that question. And what does consult mean? Does consult mean, hey, I'm going to let you know? Or does it mean they have to give me permission to do that application 3 months ahead of time? Do I have to tell them a date that I'm going to do it? Do I have to give them a date? Wouldn't make sense. Like, let's hope it's not a date, because nobody knows 3 months ahead of time. But do I have to give them like a 2-week window that I'm going to do the application? There's no clarification on what this means. But what I want to highlight is that minimization zone is 2,600 feet from the avoidance area. So if we go back to this slide, the purple areas don't overlap with corn and soybean fields that much. If you take a half-mile radius around all those purple areas, are we getting into some corn and soybean fields in Illinois? Yes. And if we're talking about greater increased regulation on those areas, what do you think that's going to do to that farmland? It's going to make it harder to farm, right? And that close to Chicago, I would argue that it's probably going to take farmland out of production. And that's the really funny thing to me. So I talked to some farmers that would be directly impacted by this. Some of them that we figured out are actually inside the purple area. And his comment was, I wouldn't be able to farm it anymore if I couldn't use pesticides. So the result would be, I would have to sell that land. Well, if you're that close to Chicago, what's the land you're selling going to go, what's going to happen to it? It's going to be urbanization. It's going to be development. What's that going to do to the habitat? It's not going to be rusty patch bumblebee habitat anymore, I can tell you that. That's my challenge, right? We're creating policy that's defeating the purpose of the policy. Also, let's think about this. What if you do conservation on the sides of your field? Maybe you don't call it conservation, but what if you do natural areas on the sides of your field that create habitat? Are you setting yourself up to be under more restrictions because you've adopted those practices? You put in a food plot, a tree stand, something like that? I don't know. That's a real question we have to ask. Are we de-incentivizing farmers to actually do more conservation with this stuff? That's a good part. Did you have a question, Burleson? You. Yeah, okay. I'm not going to, yes. Thank you for that. They do get mosquitoes in Chicago, is my understanding. So I just want to highlight this. And also, I'm just going to highlight, what are we talking about impact-wise? There's over 1 million acres of just this habitat that's being impacted if this proposal went into place. So I'm just going to wrap it up. I think I'm way over. Sorry, Jennifer. But what are my questions? What are my real concerns? First, who is legally responsible? Who's implementing this? We don't really know the answer to that. One thing that's been suggested is that the commercial applicator will be the person who's responsible. My struggle with that is, does it make sense to have the commercial applicator be the one to decide whether or not a field meets the requirements? I don't think that does. I think we have to think about that. What are the implications around lease agreements, absentee landowners, and trusts? We haven't navigated that. That's a complication I doubt the EPA has considered. Also think we have to think about what are the metrics around the agency, or what's the metrics for success? Is the metric for success no species ever goes extinct again? Because that's outside of our control in agriculture. Species go extinct and are damaged for other reasons besides what we do in farm fields. I think we have to step back to that, what is the motivation question? Because it's not clear to me, if we do this, if we spend $5 billion as the USDA estimated to implement these practices, there's no guarantee that that's the end of it. In fact, there's a real question we have to ask of, if we do all this, come into compliance, is the environmental groups or whoever that's pushing this on the back end just going to start another set of lawsuits? That's a question we have to be concerned about. We have to be thinking about, as Illinois Soybean as an organization, we're thinking about this right now. How do we address the legal concerns while we also help farmers come into compliance? And then I think there's also this piece of, can the state agencies actually do this? Is IDOA equipped to enforce this kind of stuff at this level? And I talk to a lot of my sister organizations, and the thing that they say is, Corey, I'm not worried because the state organization is never going to be able to enforce it, so it would just be a rule on the books that everyone ignores, right? Okay, so arguably that's what's happened for the last 2 years with Enlist, because most of us didn't know that an Enlist label was there. But my concern there is that that's not going to fly for very long, because we have highly motivated people on the other side that want these rules enforced. And so there will be push to, call out farmers, find examples of when farmers are failing, and maybe not sue farmers, but sue IDOA and say, hey, you have to enforce this. So this is something we can be concerned. We can't just dodge this. So anyway, with that, that's the end of my talk. I'm way over. Jennifer says I can't answer questions, so goodbye.
That's not true. He will have questions. Well, let's thank him first. Now, we do have time for questions, and I'll bring you the mic if you have a question for Corey.
So kind of like a devil's advocate, but I know, like I said, nobody says, oh, we want species to go extinct, but what if somebody did a study, said this rusty bumblebee, if it went extinct, there's no effect to the environment? At that point, what difference are we making? If we lose a species, I mean, nature gets, creates and gets rid of species all the time. So at that point, if we can say, hey, scientifically, there's no environmental effect, it's kind of a reverse it on themselves and say, hey, okay, you don't want to do it, but we can say if there's no effect, hey, so what?
Yeah, so I think that this is really a common question that I get, and I understand where it's coming from. I think first the important thing for us to understand in the short term, and when I say short term, I mean the next 10 years, the regulations that are in place now have nothing to do with whether or not the endangered species has an impact on the environment. They're listed, they're protected. So the EPA can't take an action that would damage their environment. So you maybe could do a push to get something delisted, though I don't think that would be profitable or, successful. I think we also have to remember that as an ag community, we maybe, some of us feel that way, but there's a broader community, right, in Illinois. We're all very aware of there's a broader community of Illinois that isn't as familiar with agriculture issues, and they are familiar with, they value the environment. They value the rusty patch bumblebee differently than we do. And we have to be respectful that we're part of that community, especially in an Illinois situation where we're in a deep blue state. We're in a deep environmental state. Agriculture is a top performer in the state, but we are not in an ag state. I can't lie to you and tell you that. We're not in an ag state. Even though we're #1 in soybeans, I'll tell you that all day, this is not an ag state when it comes to the politics and policies of the state. Maybe I'm coming on too strong when I say that, but I just think that that's the truth. There isn't a lot of pushback we can do in that space, and I would be fearful that pursuing that would do more damage because of the public image that would create. Do you want to say that Illinois farmers are against the teddy bear of the bumblebee world? I mean, I'm not going to promote that. Ron, are you going to support that initiative? Okay. Is that fair, though? Is that a fair? Yeah. Yeah. And a lot of this is we have to find ways to survive, to live through it. There's just an element of that.
Yep. Any other questions?
In the session yesterday, the dinner that we had, one of the presenters talked about the enforcement process for ESA violations. Do you mind going over that real quick in case folks who weren't there could hear about it, and if you have any other comments on that enforcement process and what it might mean for upcoming ESA changes?
Yeah, sure. So for sure. So you're referring to our Illinois soybean grower dinner, which if anyone's not an Illinois soybean grower member, I encourage you to become one. But the speaker was talking about enforcement, and I would argue that my biggest concern about enforcement is we don't know what that looks like. We do know that in all likelihood it will be IDOA who leads that, and I know that in my outreach to IDOA they are aware of this, but they can't really do anything until the agency finalizes their decisions. And so they can prepare and think about it, but otherwise They don't know what this looks like. I think that we, as an association, as individuals, as farmers, really need to be pushing to get further direction to our IDOA about how to handle this. I think that's something we have to talk about. And I'll caveat that with saying that, you know, IDOA is a great supporter of farmers in Illinois, and I am a big supporter of IDOA, and I'm not criticizing them in any way, but this is going to be a serious challenge for them as well. And I think they're going to need our feedback and our support to figure out how to manage it. Some other comments on enforcement. I think it's important to understand, so the herbicide strategy gets finalized May 30th of 2024, so in 3 months or whatever that is. The rollout is going to be immediate on some things, so new pesticide labels, and then it's going to come into effect on herbicide labels as they come up for re-registration. So every time a new product comes up for re-registration, there's going to be discussion about what is the ESA label on that product. And the reason I bring that up is this is going to be we're going to have lots of opportunities to discuss this moving forward for the next several years. Lots of opportunities to give feedback to the EPA, lots of opportunities to do a lot. But that's a good question, and I feel bad because I can't really answer it better because we don't know what that looks like. And I just want to be honest about that.
We'd have time for one more question.
Is the EPA, like at the tillage practices, are they the ones defining what's reduced till, mulch till, or are they going by like, I guess like a state level?
That's not totally clear, but the assumption is that they will probably go by USDA definitions or NRCS definitions. Yeah. But to be honest, that's not fully clarified in the document. And these are the things that are going to have to get worked out after the fact.
All right, let's thank Corey one more time. All right, so thank you again to Corey and to Benson Hill for sponsoring this session. If you are a CCA, we do have the sheet in the back to sign up for credits. And again, this is our last session, everyone. So thank you so much for joining us today for Soybean Summit. And do remember there is a poster session for students back where we got your lunch. And so please go check that out, say hi to the students, and learn about their research. But other than that, have a safe drive home, and thank you so much for attending today.